16. An alternative population genetics model. Ola Hostja, and K. Gager, and Colin R. Reeves. Summary. What can be said about human history from DNA variation among us today? Population genetics is used in academia to infer that we share a common ancestry with apes, that most of our human ancestors emigrated from Africa 50,000 years ago, that they possibly had some mixing with Neanderthals, Denisovans, and other archaic populations, and that the early Homo population was never smaller than a few thousand individuals. It uses mathematical principles for how the genetic composition of a population changes over time through mutation, natural selection, genetic drift, and other forces of change. In this chapter we investigate the assumptions about this theory and conclude that it is full of gaps and weaknesses. We argue that a unique origin model, where humanity arose from one single couple, seems to explain data at least as well, if not better. We finally propose an alternative simulation approach that could be used in order to validate such a model. We all have a genetic fingerprint. The more closely related we are, the more similar our fingerprints. Genetic data can be used for a number of purposes: to find out whether we carry a risk gene of an inheritable disease, to ascertain that a young man is the father of a newborn child, to find evidence against a suspect of a crime, or to retrieve our ethnic mix at Ancestry.com. In this chapter we will investigate what human genetic data has to say about common ancestry. In academia, the prevailing view is that human beings are descendants of ape-like ancestors, whose numbers were never less than a few thousand individuals at any time in history. There is another possible scenario, though, that of an original first pair. This scenario has never been adequately tested scientifically using the methods of population genetics. Given the importance of this subject, it is imperative to rigorously examine both scenarios. In this chapter we describe a method to test them against each other. Population genetics. Population genetics is a discipline that describes how the genetic makeup of a group of people changes over time. It has numerous applications, but here we will use it as a tool for comparing different scenarios of human history. Before doing so, we will first review some basic principles of genetics. Genetic information is stored in all of our cells as 46 chromosomes, 23 of which are inherited from our father and 23 from our mother. 44 of these are non-sex, autosomal, chromosomes and come in almost identical, homologous, pairs. The remaining 2 chromosomes determine our sex. Females have 2 copies of an X chromosome, one from each parent, whereas males have 1 Y chromosome from the father, and 1 X chromosome from the mother. There is also genetic information in the mitochondria, organelles in our cells, inherited from our mothers. The 46 chromosomes of the cell nucleus and the mitochondria of the cell cytoplasm are molecules. The genetic information is stored in these molecules as nucleotides of A, C, T, and G, linked together to form the double-stranded DNA helix. Each nucleotide, or base, pairs with another in a stereotypical fashion, A with T and C with G, see Figure 16.1. The sum total of the DNA in our cells, our genome, can be thought of as a book with 3 billion base pairs of DNA. Most parts of DNA are the same for all humans, but those that vary are called polymorphisms. They are the ones that make us genetically unique. A single nucleotide polymorphism, SNP, is the most common kind of variation. For each base pair of the DNA molecule, the convention is to refer to only one of its 2 nucleotides, the one located on the coding strand. This nucleotide usually exists in 2 variants at an SNP, for instance C or T, also referred to as the 2 alleles of the SNP. A typical genome differs from the human reference sequence, which has the most common SNP at all positions, at about 4 to 5 million nucleotides, slightly more than 0.1% of the human genome. Since our genomes are not identical, population genetics can tell us something about human variation and history. We can study how big the genetic differences in the worldwide human population are, and indirectly how these differences have changed in the past. We can also compare the genetic makeup of individuals from different regions like Europe, Africa, Middle East, or East Asia, or study smaller groups of people, like the inhabitants of Sardinia, Iceland, or Polynesia. Population genetics is a discipline that uses mathematical methods to quantify how genetic differences vary among individuals, between geographic regions, and over time. Starting in the 1920s, much of its theory was built by prominent mathematicians and geneticists like Ronald Fisher, Sewell Wright, John Haldane, Motu Kimura, and Samuel Carlin. Its theory is built on the principle of small stepwise changes, and as such is a good tool for describing microevolution within species, and some limited degree of speciation. This has many applications, for instance animal and plant breeding, and also wildlife management and conservation biology, where the viability of species, their adaptation to environmental changes, and inbreeding can be quantified and estimated over time. However, population genetics was also intended as a method to explain how small changes could lead to big ones. In other words, it was largely founded to support macroevolution and common descent, based on the idea that macroevolution was merely microevolution writ large. But today it is possible to use it for the opposite purpose, to show how unlikely macroevolution is. In the following sections, we will describe this in more detail. 2. Mechanisms of population change. Our genomes are scrambled images of our ancestors' genomes. In order to understand how history has scrambled our ancestral DNA, we first need to describe mechanisms that cause the genetic composition of a population to change over time. These mechanisms reflect population behavior, demography, as well as genetic inheritance, and thus can tell us something about a population's history. They can be summarized as follows. Mutations are changes to DNA. These mutations are typically copying errors. The ones of interest in population genetics are those that occur when germ cells are formed during a special type of cell division called meiosis, which halves the genetic material of ordinary cells and reduces the number of chromosomes from 46 to 23. These mutations are important since they spread to all cells of the offspring after fertilization. Suppose, for instance, that a single nucleotide of a non-sex chromosome is changed from an A to a G in a sperm cell, which fertilizes an egg. The probability of mutation occurring is very small, about 10 to 8 per nucleotide per generation in nuclear DNA. As the resulting embryo develops, all the cells inherit that mutated allele G from the father, as well the mother's version, say, A. The two versions of the inherited DNA form a pair, AG, of alleles in the new individual. That individual will in turn pass on either the A or the G to each of its offspring, at random usually. Mutations also occur in sex chromosomes and mitochondrial DNA. Genetic drift means that alleles will change in their frequency from one generation to the next simply by chance. Some alleles may be passed more often to the next generation, and some less often. Say, for example, a certain SNP has alleles A and T. If a woman with two copies of A, allele pair AA, has no children, then neither of the two copies will be passed on to the next generation. If many other individuals with allele pair AA happen to have fewer children, by chance, than those with allele pair TT, or those parents with allele pair AT happen to pass on T to their children more often than A, the overall effect is that the frequency of A decreases and that of T increases. Natural selection is similar to genetic drift. Some parents have higher fitness and produce more offspring than others, due to differences in their ability to have children, or differences in the survival of their children to the next generation. If parents with more copies of a certain allele, say, A, at an SNP tend to be more fit than those that have more copies of the other allele, say, T, the frequency of A will increase in the next generation, and eventually T may disappear in the whole population. On the other hand, if individuals with one copy each of A and T, allele pair AT, are more fit, the frequency of both alleles will tend to stabilize over time. Recombination is a way of generating more diversity between chromosomes, by shuffling the arrangement of alleles along the chromosomes. No novel DNA is produced, but existing DNA is combined in new ways, see Figure 16.2. Recombinations make variation at different parts of the chromosome more independent, as they gradually break up association between alleles. This happens, for example, in Figure 16.2 between A at the first SNP on chromosome 1 and C at the second SNP. Since recombinations occur more often if the SNPs are far apart, the association between a distant SNP pair will tend to be smaller. Colonization, isolation, and migration. Especially in the past, humans have been more or less isolated by distance, with mating couples living nearby. Sometimes new subpopulations are formed, colonization, and occasionally men or women migrate over longer distances to find their spouses. It is evident that migration will decrease the differences between subpopulations, whereas isolation will increase them. 3. Statistics describing genetic variation in a population. There are certain statistics that describe the current genetic variation of the human population. Nucleotide, or allelic, diversity roughly says how many SNPs there are in the overall population. Allele frequency spectra show how many rare and common alleles there are in the population. Linkage disequilibrium, LD, plots give a description of how recombination has affected the variation we see along chromosomes today. The more recombination events there were in the past, the shorter are the chunks of DNA that have been inherited together. There are also other statistics that can be used to describe the degree of differentiation between subpopulations. When population geneticists try to reconstruct human history from genetic data, they combine different demographic scenarios, population size changes, colonization, and migration, for example, with the genetic mechanisms of mutations, recombinations, genetic drift, and selection, to see how well these scenarios reconstruct the statistics mentioned above. There are highly sophisticated mathematical methods for doing this, but it is still very difficult to reconstruct human history. The main reason for this is lack of data from the past. It is indeed possible to sequence DNA from ancient people such as Neanderthals, and in recent years this line of research has exploded. In spite of these advances, ancient DNA is still so sparse that, to a large extent, genetic analyses of human history will continue to rely on DNA samples from the most recent generations. With little historical data, any reconstructed genealogy is an estimate only, with assumptions embedded in it. In order to illustrate how the past has shaped the genetic variation of today, let us consider allelic diversity. It is a balance between genetic drift, mutations, recombinations, selection, and migration. Genetic drift will first of all decrease diversity, since some alleles are lost by chance, and this happens much more quickly the smaller a population is. Mutations and recombinations, on the other hand, will increase diversity, since either new alleles enter the population, or existing ones are combined in new ways. Natural selection may either increase or decrease allelic diversity. Diversity will decrease if alleles with higher fitness take over, or if deleterious alleles are lost, whereas diversity increases if coexisting alleles have a selective advantage. Migration and colonization shuffles around existing alleles between subpopulations. The more isolated subpopulations are, and the less migration there is between them, the larger is the diversity in the whole population, since different alleles tend to take over in different subpopulations, whereas the diversity in each subpopulation decreases due to the isolation. 4. Alternate human histories. There are two important, controversial, and interwoven aspects of human history: the age of our initial population, and its size. Age. How can we use allelic diversity to say something about age? Because of the balance between genetic drift on one hand, and mutations and recombinations on the other, population geneticists argue that the younger a population is, or the more recently in the past its size was drastically reduced, a so-called bottleneck, the less variation we see among the members of the population alive today, since there has been less time for mutations to produce new variants. A small amount of diversity therefore indicates a young population, or an old population that recently went through a severe bottleneck. More refined conclusions can be drawn if we also take the other statistics, allele frequency spectra, LD plots, and subpopulation differentiation, into account. For instance, the LD plot of an older population reveals that shorter segments of DNA have been inherited together, since there has been more time for recombinations to shuffle around chromosome segments. Size. Based on genetic diversity and these other statistics, population geneticists estimate that our population never contained less than several thousand individuals to account for current diversity, and that it probably contained about 10,000 at the time of our last common ancestor with chimps, which they estimate to be about 6 million years ago. The rationale of this argument is that the diversity we see in human DNA today is not only too large to be explained by a single founding couple. It is also too large to be explained by an old population that more recently went through a bottleneck much smaller than a few thousand individuals. It is possible, however, that a first founding couple were created with initial diversity, each individual with 22 pairs of autosomal chromosomes and either an 20 for the female or an XY for the male. Thus there would have been 4 total copies of each non-sex chromosome, 2 from each. Those 4 copies could each have been created unique, giving rise to a very large number of SNPs, all of which were present in the first generation. This could be true for all of the 22 sets of 4 homologous chromosomes. In the same way, the 3 X chromosomes copies, 2 for the female and 1 for the male, could have been created with diversity. Some diversity from the first generation is also possible for mitochondrial DNA. Since the female carried hundreds of mitochondria that could have been diverse, she may have passed some of that diversity on to her daughters. So we now have 2 competing hypotheses: common descent of humans with other species, or a unique origin for a first founding couple with created diversity. In the next section we will juxtapose these 2 models of human history, the standard model that assumes common descent, and the other model that assumes we came from 2 first parents, unique origin. The 2 models have different starting assumptions, but follow the same rules of inheritance and population genetics in their working out. 5. The competing models. A. Common descent model. The most widely accepted common descent theory of humanity currently holds that our ancestors diverged from chimps about 6 million years ago. Then a hominid species Homo erectus evolved in Africa. It spread to Europe and Asia about 2 million years ago. Various archaic species are believed to have evolved from Homo erectus over the past 500,000 to 800,000 years, including Neanderthals in Europe and Denisovans in Asia. See Chapter 14 for more on this subject. There are 2 main variants within this framework for how Homo sapiens, our species, came about. Out of Africa replacement model. According to this theory, modern humans evolved from Homo erectus in Africa 100,000 to 200,000 years ago. Then they went through a bottleneck that reduced the population size to an order of 10,000 individuals or smaller. A large part of this group emigrated from Africa about 50,000 years ago to the Middle East, Europe, East Asia, and America, gradually replacing existing archaic species. After leaving Africa, all non-African populations have experienced much more recent and long-lasting bottlenecks before they started to grow. Multi-regional evolution posits that our ancestors evolved in parallel from archaic species in several parts of the world, possibly with an African dominance. As a consequence, we have to trace human lineages up to 2 million years before they all end up in Africa. The replacement model has been the most popular common descent model of human history for several decades, but there is no distinct boundary between it and multi-regional evolution. An out-of-Africa scenario with some interbreeding with archaic populations is not too different from a multi-regional model with an African dominance. Over the past few years, ancient DNA has been retrieved from Neanderthal and Denisovan bones in different parts of the world and compared with that of present-day humans. These studies reveal that all human populations except sub-Saharan Africans have about 1 to 2% of Neanderthal DNA. In fact, it seems that as much as 40% of Neanderthal DNA is found in at least some individuals alive today. Lower levels, fractions of 1%, of Denisovan ancestry can be found mainly in Southeast Asia, Oceania, and among Native Americans. This has caused many researchers to adopt a hybrid of the replacement and multi-regional models, according to which our ancestors originated from Africa but still had some interbreeding with archaic populations. B. Unique origin model. By a unique origin model we mean one in which humanity originates from a single couple. There is still the question of geographic origin. There are at least 2 versions of the unique origin model, with different geographic ancestry. African ancestry. This is a scenario by which the first couple lived in Africa. It has many similarities with the out-of-Africa model, except for the unique origin assumption. The subsequent migration scenario out of Africa could be similar for both models. In the next section we will argue that a unique origin with an African ancestry typically gives old estimates for the age of humanity. Middle East ancestry posits that the most recent common ancestors, MRCA, of all humans lived in the Middle East. The subsequent migration from Middle East to Europe, Asia, America, and Oceania could be similar to that of the out of Africa and the African unique origin models discussed earlier, in that the migration is in the same general direction. However, this model differs from the African ancestry model and out of Africa models by proposing that Africa was colonized from the Middle East rather than the opposite. In the next section we will argue that, in light of genetics, this gives a much younger age of humanity. 6. Comparison of the models. The crucial question is which of the different scenarios of common descent or unique origin in Section 5 the actual genetic data supports the most. We will consider the evidence in several parts. Differences with other species. A major drawback of the common descent models is the difficulty with handling the significant genetic differences between humans and other species. This is treated in detail in Chapter 14. There are indeed research papers that try to estimate a common genealogy of humans, chimps, and gorillas, using those parts of their genomes that show more similarity, but comparisons of this kind have limited scope, since they focus too little on the regions where the species differ. Models that compare human DNA with that of other species should incorporate the difficulty for mutations and other genome arrangements to build up such genomic interspecies divergence, as well as anatomical and physiological differences. Other studies that take this into account typically reveal that the time it takes for these mutations to appear and be fixed in the population is much longer than what macroevolution requires. Variability in human genetic data. The main argument against a unique origin is that the nucleotide diversity within the human population seems too high to make a single founding couple possible. But this is not a problem for non-sex and X-chromosome DNA if there was initial created diversity. Although it is not possible to invoke created diversity for Y chromosomes, recent studies have shown that its diversity is in fact a lot smaller than for other types of DNA. Genetic data also indicates that all non-African populations are quite closely related. According to the out of Africa model, this is explained by a severe and very recent bottleneck, of the order 10,000 to 50,000 years ago, that the non-African ancestors supposedly experienced. This is perhaps the main reason why this model is more popular today than multi-regional evolution. African populations, on the other hand, look older, at least at first sight. There are also considerable genetic differences between African groups, indicating that their ancestors lived in small and relatively isolated tribes. Out of Africa model adherents interpret the bottleneck that the ancestors of all non-Africans supposedly experienced as descendants of a few thousand people that migrated out of Africa. For a long time the non-African population stayed very small, but then they quickly expanded and diverged. These arguments for the out of Africa model seem convincing at first. But they could also be used for a unique origin model with an old African ancestry. The only difference is that the ancestral population of all people alive today, supposed to have lived in Africa before the migration and expansion to other continents took place, is a single couple with created diversity. But what about a founding couple from the Middle East? Is this unique origin version incompatible with data? Not necessarily. This model requires that the age of humanity is much more recent. The reason is that the originating pair replaces the long-lasting bottleneck that supposedly occurred after immigration to the Middle East from Africa. And the genetic diversity that remains after this bottleneck population is replaced by created diversity in the first pair. This would explain the relatively large genetic variability we find among humans of today for non-sex and X-chromosome DNA. Recall that the diversity of Y chromosomes is much smaller. A recent paper that compared sequences among Y chromosomes found that a large group of Africans are in fact more related to non-Africans than to all other Africans. A possible explanation for this is several migration events into Africa from the Middle East. There are also tentative explanations within the Middle East unique origin framework for the observation that African populations look older than non-African ones for non-sex and sex chromosome DNA. Future research will tell how credible these explanations are. Block structure of DNA. A large part of our autosomal and X chromosomes have apparently been recombined into blocks of varying length. Many of them are on the order of 10,000 nucleotides long, but the variation in length is large. But even though the blocks are long, there is still very little variation within them. Each block comes in just a few variants, for many parts of the genome. Our chromosomes are different mosaics of these block variants. This DNA block structure is remarkably consistent with a unique origin hypothesis. If the first couple originated with DNA diversity, there would have been 4 different copies of each autosomal chromosome, 2 for each individual. Their 4 chromosomes have since been scrambled by ancestral recombinations, and today each of us has one mosaic of the 4 founder chromosomes inherited from our father, and another one from our mother. Inbreeding depression and genetic entropy. It is well known that many alleles will be lost due to genetic drift when a population experiences a severe bottleneck. The long-term consequence is a decreased ability for long-term adjustment to environmental changes, but there is also a more acute risk of inbreeding depression when the frequency of recessive disorders increases, as more offspring receive from both of their parents a harmful variant of a disease-causing gene. The smaller the population is during the bottleneck, and the longer time it takes before its size starts to increase, the more severe are the consequences for the population's viability, so that ultimately it may die out. Conservation biologists have devised rules for minimal population sizes in order to ensure short- and long-term protection of animal species. For humans, there are several well-known examples of the drastic effects of continued inbreeding, such as the extinction of the Spanish Habsburg dynasty around 1700 and the high occurrence of a severe form of color blindness on the Micronesian atoll of Pinglap, after a typhoon hit the island in 1775 and 90% of the inhabitants died. All present-day inhabitants can trace their ancestry to one of the survivors that carried the harmful variant of the gene that codes for this type of color blindness. Inbreeding depression is potentially a difficulty for the common descent model. Recent calculations reveal that the model predicts a very small bottleneck, of the order a few thousand individuals, and that it lasted for at least 1,000 generations. In spite of this, the survivors of the bottleneck are believed to have expanded, to conquer the rest of the world. A unique origin model avoids, to some extent, the problem of inbreeding depression if the created diversity of the first pair had only neutral variants, whereas the harmful ones occurred later through germline mutations. The younger the population is, the shorter is the time for such germline mutations to occur, and the smaller is the risk of inbreeding depression. For a similar reason, a model with a young age of humanity has another advantage: it can handle the problem that the slightly deleterious mutations are so many that natural selection cannot remove them all. For an old population, as the mutations accumulate over time, the technical term for this is that the genetic entropy increases. They can have potentially very damaging effects. But if the pair lived recently, and if all present-day harmful variants arrived only through mutations in their descendants, there has not been enough time to accumulate them into large numbers. In contrast, any model with an old age of humanity faces a problem, since either the number of slightly deleterious or deleterious alleles increases, or a bottleneck occurred that removed some of these harmful variants, but at the cost of spreading others that could initiate inbreeding depression. Archaic populations, humans or not. As mentioned in Section 5 of this chapter, significant fragments of Neanderthal and Denisovan DNA have been found among present-day humans, so researchers suggested that some interbreeding took place between archaic populations and the ancient humans that supposedly emigrated out of Africa. This admixture is believed to have happened at least 50,000 years ago, and probably later on as well. It is in fact well known that gene flow between closely related populations is helpful in order to increase genetic variability and to avoid inbreeding, and indeed, the archaic introgression is believed to have had positive effects, like helping the Tibetans to adapt to high altitudes, and the non-Africans in general to adapt to colder temperature and to ward off infections. But the common descent model predicts a split between humans and archaic hominins more than 500,000 years ago. It would therefore be remarkable if two populations, after such a long time of separation, were still able to have fertile offspring. But even if this were possible, because of the long separation, it is reasonable to believe that the offspring had low fitness, since our archaic ancestors had, most likely, accumulated many alleles which were deleterious for humans, before the admixture took place. In view of this, it seems that the large fraction of archaic DNA among present-day humans is more reconcilable with a unique origin model, in which Neanderthals and Denisovans are descendants of the originating pair and hence are our fully human relatives. Conclusions. We have argued that a unique origin model, with either a young or an old age of humanity, with created diversity should have at least the same explanatory power for human genetic data as the most popular common descent scenario of today. Any model must be able to explain the big genetic differences between humans and other species, solve the problem of inbreeding depression, support the viability of human and archaic population admixtures, and give reasons why our DNA resembles a mosaic of about 4 founder genomes. The conclusion is that the unique origin model seems more plausible. 7. Testing of the models. The qualitative arguments of Section 5 lead us to conclude that the unique origin scenario of human history seems plausible. It is of interest to follow this up in a more formal way. The basic idea is to simulate genetic data from each proposed model many times, and then compare how well the simulated output fits real data. This comparison should include nucleotide diversity, allele frequency spectra, LD plots, and other statistics. There are at least 2 different ways to proceed with these simulations. Forward simulation. The most straightforward way of simulating genetic data is to start at the founder generation and then proceed forward in time. For each simulation round, one first assigns genomes to the first pair of humans. Demographic and genetic data are then simulated one generation at a time, using the hereditary principles of Section 2. The main advantage of forward simulation is its great flexibility. Virtually any type of model for human history can be simulated and validated with real data. But the method requires that DNA of all humans is simulated. In view of the size of the worldwide human population, this is computationally very demanding, and requires long execution times. Backward simulation. There is another much faster simulation algorithm. A more detailed description of it can be found elsewhere. In each simulation round, only a small subset of genetic data is generated. The main idea is first to select a small sample of humans alive today, for instance, a few thousand individuals, then simulate their genealogy backwards in time, using a method called coalescence theory, until the founder generation is reached. When the genealogy has been generated, DNA is assigned, first to the founders, and then forward in time to all their descendants along the branches of the simulated genealogy. The genealogy will be only a small subset of the ancestral human population. We refer to this method as backward simulation since the genealogy is simulated backwards in time. We are currently working on implementing a model based on backward simulation. The intent is to validate it with real data. This is a long-term project, whose outcome we hope to publish elsewhere. Using this approach, our intent is to demonstrate that a unique origin model is able to replicate current human diversity as well as or better than the common descent model. That is the purpose of the model, to test this possibility. Therefore, if more than one plausible account of human origins can explain the data, the common descent model of our origin from ape-like ancestors can no longer be claimed as conclusive proof that there could not have been a single first pair. Here we complete our one long argument for a unique origin for humanity begun in Chapter 13 with an outline of the importance of the question. In chapters 14 through 16 we have shown that the fossil evidence shows an absence of intermediates between ape-like fossils and human ones, indicating that the story told by evolutionists of a well-documented continuous bridge between the two is false. The genetic evidence shows there are many more uniquely human elements in our genome than are commonly ascribed to it, significantly more than the oft-quoted 1% genetic difference between chimpanzees and us. Many of these elements come from what used to be called junk DNA, but are now thought to be functionally significant. There isn't enough time for all these differences to have been selected and fixed in the ancestral human population by purely natural means. Population genetics models that say we had to come from an original population of thousands rather than 2 are subject to question, and can be tested against an alternative model starting with just 2 first parents. Taken together, our argument leads to the conclusion that it is unwarranted to discard traditional interpretations of our origin. 17. Pressure to conform leads to bias in science. Christopher Shaw. Summary. Science has become all-pervasive in modern society and is regarded by many as the means to solve all of our major problems. For many, science has become a new religion, endowed with an infallibility extending even to answering the fundamental questions about our origins and the purpose of our existence, questions that once were the subject matter of philosophers and religious scholars. As a consequence of this new role, the scientific process has been increasingly departing from its objective basis to one of crass subjectivity, with regular highly speculative claims being made by renowned scientists in the popular media and even in the scientific press. Phrases such as we believe that have become common among some scientists, particularly in the fields of evolutionary biology and cosmology. The high priests of this new religion, we'll call it scientism, are the worst offenders, and many have achieved international celebrity status. But there is also a largely unknown dark side to this new religion: control of the freedom of thought. As acknowledged by the majority of scientists, the allocation of research funding and the peer review system of scientific publication are both seriously flawed and serve to maintain the status quo within the establishment by filtering out perceived intellectual heretics. New thoughts, ideas, and insights are often viewed with suspicion and require evaluation not only of their worth but also, increasingly, of their potential to challenge widely accepted dogma. Indeed, this has been an almost universal experience in the early, ridicule-fraught careers of most Nobel laureates in the sciences. New recruits to the system must obey the rules if they wish to obtain training positions, tenure, and career progression. Scientism, the new religion. Scientific advances in the past 200 years have been instrumental in producing rapid changes in virtually every aspect of life, particularly with regard to the global environmental changes associated with expanding human agriculture and industry required to feed and maintain a burgeoning human population. Science has produced numerous benefits for humanity in terms of technological innovations that have generated unprecedented advances in healthcare, nutrition, and telecommunications. The apparent solutions to many of life's problems and the relatively cozy lives of people in developed nations has led to the demise of traditional Christian beliefs and their replacement by the new religion of scientism. The rationale for this is simple: why feel obliged to abide by the often inconvenient and lifestyle-intruding rules of a superior being, a creator God, when science is solving all of our problems? The Church of Scientism has its anti-theist prophets and priesthood who pervade almost all aspects of modern life, and who pursue this new religion with an almost unequaled evangelistic zeal, beginning in our schools and continuing into higher education. Those who do not convert but maintain their biblical beliefs are often subjected to name-calling, usually with an implication of low intelligence. Interestingly, as we shall see, the same strategy is used for scientists who challenge the accepted scientific dogma of the establishment. Basically, the Catechism of Scientism states that the universe and life arose through cosmic accidents over vast periods of time, and that therefore our human existence has no defined purpose. Individuals are free to do as they please, as there is no rational scientific basis for moral concepts such as good and bad. We are told that we are not alone in the universe and that, indeed, many universes may exist, of which ours is only one. These dogmas are not, as one would expect, based on scientific proof in the form of reproducible experimental evidence, but rather are based on speculation or individual beliefs. Stephen Hawking, quoted in the Mail Online in an article titled "New Hunt for Alien Life," said, "We believe that life arose spontaneously on Earth. So in an infinite universe, there must be other occurrences of life. Somewhere in the cosmos, perhaps, intelligent life may be watching these lights of ours, aware of what they mean. Or do our lights wander a lifeless cosmos, unseen beacons, announcing that here, on one rock, the universe discovered its existence? Either way, there is no bigger question we must know." Such statements would not be considered scientific, and are more consistent with a religious belief system, but, being uttered by one of the most high-profile scientists of our time, they are taken by the general public as factual and true. Such subjective commentaries from eminent scientists are now commonplace, and many, especially the young, are being subconsciously initiated into the new religion. Evolutionary theory was one of the first areas of science to travel this path, and any alternative explanations or beliefs concerning life's origins or diversity are treated as heresies in the vast majority of schools. Deviation from this establishment dogma by teachers can result, and indeed has resulted, in litigation or dismissal from employment. Among his great scientific achievements, Craig Venter, an entrepreneurial molecular biologist, succeeded in making the first synthetic bacterial cell, which he named Cynthia. Many scientists and non-scientists claimed that Venter was playing God, a claim that Venter denied, saying that he could not be modeling himself on someone he did not believe in. When an interview pointed out that some scientists did not rule out belief in God, Venter replied that it was their issue to reconcile, not his, and that for him, it was either faith or science, one could not have both. Of course, many scientists have had long and distinguished careers while maintaining their belief in God and, indeed, many of the fundamentals of a variety of scientific disciplines were put in place by just such people. I often smile when discussing Venter's creation of Cynthia, as I see this as a great example of intelligent design, albeit a much less complex derivative of the original version. In an interview for the King's Review magazine, the eminent scientist Sidney Brenner commented about his experience as a scientist in the early days in the mid-20th century, a time of unparalleled fundamental biological discovery, as he worked at Cambridge with pioneering innovators such as Max Perutz, Francis Crick, and Fred Sanger, all of whom became Nobel laureates. What people don't realize is that at the beginning, it was just a handful of people who saw the light, if I can put it that way. So it was like belonging to an evangelical sect, because there were so few of us, and all the others sort of thought that there was something wrong with us. They weren't willing to believe. Of course they just said, well, what you're trying to do is impossible. I remember when going to London to talk at meetings, people used to ask me what I am going to do in London, and I used to tell them I'm going to preach to the heathens. So the message of true scientific innovation is often treated with ridicule by one's peers, and it takes a special type of person to persevere and ultimately win the day. Without this unified and determined focus, the discipline of molecular biology would not have been born when it was. Brenner went on in this interview to say, I think that being in science is the most incredible experience to have, and I now spend quite a lot of my time trying to help the younger people in science to enjoy it and not to feel that they are part of some gigantic machine, which a lot of people feel today. In the following sections, we will consider some of the reasons why young scientists feel that way. 2. The typical paths followed by a career scientist. After graduating from high school, a young person wishing to pursue a career in science will carefully choose an undergraduate degree course in their area of interest, usually in a university with a good reputation in that discipline. After a number of years, usually between 3 and 5, they will emerge with an undergraduate degree in their chosen subject. The potential career pathways that can be followed at this stage are varied. Graduates may leave university at this point and enter the job market directly, especially if their qualification is vocational. Those who aspire to be high school teachers will usually then obtain a postgraduate teaching qualification and enter that venerable career. Those who develop an interest in scientific research, however, are really just at the beginning of a period of intense postgraduate study which may involve 1 to 3 years of study in a more specialized master's program with both classroom and research project elements, followed by a PhD program of even more specialized research of 3 to 7 years duration. Many industries require scientists seeking positions in research and development to be qualified to the PhD level, and a considerable number of those who achieve this level of Education will avail themselves of such jobs at this stage. These relatively well-paying jobs are favored by many who are worried by the often sizable debts incurred to reach this point. By now, they may be nearing 30 years of age. For those who remain, who have a passion to pursue a career in academic scientific research, a series of postdoctoral research fellow positions now have to be obtained in order to acquire relevant experience in even more specialized techniques in increasingly specialized areas of research. The competition for these positions is even more intense than for those already described. To obtain the requisite positions, candidates may have to travel extensively, with associated costs of relocation, etc. After successful completion of an average of 2 such positions, with associated appropriate academic outputs, the aspiring research scientists, now in their mid-30s, will be in a position to apply for the even rarer tenured or tenure-track academic jobs, for which competition is fierce. At this career stage, the candidates will have been studying or working on small incomes for an average of 15 years, and this takes its toll on many of them, not least in their social and personal lives. For the few who obtain tenured or tenure-track positions, while many battles have been fought and won, the war is not yet over. These positions invariably have periods of probation of sometimes 3 years duration, after which the relative security of tenure will be achieved subject to a satisfactory performance as judged by faculty and/or university administration. Such performance indicators may include quantity of research grant income, number and quality of research publications, and assessments by the undergraduate students they have taught. In fact, in many institutions, established academics are subjected to regular performance assessments, the results of which may determine salary increments, progression to higher grades, and, in some instances, maintaining positions per se. It is thus not surprising that, after undergoing such stringent selection procedures, those who emerge at the end of the process are highly talented, highly motivated, determined individuals. However, they are thus, for the most part, highly unlikely to do anything that would serve to create dissent or engender disfavor within their respective university or scientific establishments. For the not unreasonable fear of losing all that they have strived to obtain. The common view that scientists are free thinkers who are open to all new ideas and can pursue such without hindrance is not what occurs in reality, and the following sections give some insights into how controls occur in internal university appraisal processes, the obtaining of external income for research, the peer-reviewed publication of results, and how these factors relate to one another. 3. The financing of research through externally acquired income. A colleague of mine once said, in response to a question from the dean as to why he was considerably more successful than his peers in obtaining external research income, that he only wrote an application for funding when he had a good and novel idea. This would probably be the general impression of the public, but it is apparent rather than real. It may come as a surprise to many that the topics of scientific research are actually not chosen by the applying scientists but rather by the funders themselves. These research themes and special initiatives are driven largely by economic and political agendas and are not curiosity-driven by the scientists themselves, hence the drive toward applied research and away from individual curiosity-inspired questions. While this situation could be deemed a logical path in the maximizing of research efforts for economic benefits, especially considering that much of the research depends on public funds, it actually serves to prevent innovators from pursuing projects that would be considered unconventional, and this is exactly where true innovative discoveries most often arise. External income for university research comes from a multitude of sources, including federal or other government funding, charities devoted to specific issues, industry, philanthropy, and bequests. Income can be defined in several ways, such as that for specific projects addressing specific research questions, for major equipment, and for new infrastructure. While each source of income can be approached for all of these uses, the major sources of external income for specific research projects tends to be government, charities, and industry. Each source works in different ways, with different agendas. The funding from government sources is divided across organizations of broad research focus, which are subdivided into panels of discrete interests or themes, which may in turn be subdivided from time to time into special initiative groups. Applications are usually externally peer-reviewed, by reviewers who are chosen either from those nominated by the applicant or from those nominated by the panel, or a mixture of both. Final funding decisions are made by the specific panel, taking external peer reviews and ratings into account, and often after supplying the applicants with questions or comments arising from this process for reply, prior to the final decision. It is not uncommon for these comments to be highly subjective and to clearly show that the reviewers have either not carefully read or have not understood the application. Charities tend to have scientific advisory boards consisting of specialists in their areas of focus, such as in a particular disease, and they often employ external peer review as well in their decision-making processes. Industry will, for reasons of intellectual security, review grants internally by specialist consultants and team leaders and usually will fund areas of specific commercial interest to their company but may also fund more fundamental research if deemed to be of strategic importance. While various sources of external research income are very important to the research machine, the most favored and predominant are those from government sources. There are several reasons for this, including the fact that it is the most highly competitive source, but also that such grants often cover full economic costs of the research for the university administration. The highly competitive nature of acquiring such funding, often no more than 10% of applications are successful, is commonly used by administrators as an index of the quality of the applicant's research, which can have promotion implications. And, of course, these grants oil the bureaucratic machine. For these reasons, scientists are encouraged to apply to such sources as a top priority. A well-written application may take several months to write and, with a low level of potential success, it places a considerable burden on researchers. Can one imagine a recently established researcher writing an application which challenges accepted dogma or which proposes a new idea, bearing in mind that those who make the final decisions on funding have built careers on established dogma and may even be the authors of such? When one takes into account everything that is at stake in this process, it is not surprising that the vast majority of applicants decide not to be too critical of what has gone before but rather to describe an incremental study based on what has been previously published. The names and affiliations of panel members on national research funding bodies are usually published, and it would be foolish not to avail oneself of information about them through examination of their own publications. Since many universities have representatives on the panels of national research bodies, it is often useful to have a chat with such persons prior to submission of applications. There is a lot at stake in this process, and of all that is expected of a university academic, it is probably the area that causes the most stress, due to the enormous uncertainty of success. An eminent colleague of mine, with a good track record in research funding, while addressing a group of newly recruited scientists, was asked what the difference is between a successful and an unsuccessful application. He replied that he could not answer that question as, in his opinion, he had written superb applications that had not been funded and others that he thought less highly of that were funded. In essence, all things being equal, funding is largely no more than a lottery, perhaps being decided by no more than one reviewer having a bad day before writing his or her report or by someone who is not familiar with the science producing an erroneous assessment. Sir Harry Kroto, 1996 Nobel Prize winner in chemistry for the discovery of carbon-60, in an interview with the Guardian newspaper, recalled, "You hear through the grapevine that you're in the running for the prize, but on the day I forgot all about it and went to the pub for lunch." The timing had a nice irony, for only hours before, causing huge embarrassment for the Engineering and Physical Science Research Council, UK, he had been refused a £100,000 grant for research into exactly the same subject. Sidney Brenner describes the current situation in obtaining research funding in his own inimitable style. "Even God wouldn't get a grant today because somebody on the committee would say, oh, those were very interesting experiments, creating the universe, but they've never been repeated. And then someone else would say, yes, and he did it a long time ago, what's he done recently? And a third would say, to top it all, he published it all in an UN referee journal, the Bible." So, to summarize, the system of training and employing young scientists requires many years, as many as 15, of hard work and monetary investment in a highly competitive environment. The endpoint of this effort is a tenured or tenure-track position as a university academic, but the selection process does not end here. The acquisition of external research income is a major factor in establishing tenure and is used by administrators in deciding on career progression, often through rigorous annual appraisal procedures. Achieving success in this arena largely precludes the high risk of proposing new ideas in applications, and most scientists adopt the incremental approach to research which does not attack or question established thinking. So much for the popular public view that academic research scientists are unrestrained free thinkers. 4. The peer-reviewed publication process. The peer-reviewed publication process can be defined as the review of a scientific manuscript by a small number of scientists working in the same field as the subject matter of the submitted work, objectively assessing its quality. Most scientists would question the objectivity of this process, but the general feeling is that it is the best we have in the absence of an alternative. But is it really good enough, in the 21st century, to have a subjective system which has endemic bias and which can effectively undermine the dissemination of new information and ideas, and can influence the careers of academics in an unfair and unregulated manner? In a tribute to his colleague Fred Sanger, Nobel Prizes in Chemistry, 1958 and 1980, published in Science, Sidney Brenner wrote, "A Fred Sanger would not survive today's world of science. With continuous reporting and appraisals, some committee would note that he published little of import between insulin in 1952 and his first paper on RNA sequencing in 1967, with another long gap until DNA sequencing in 1977. He would be labeled as unproductive, and his modest personal support would be denied. We no longer have a culture that allows individuals to embark on long-term, and what would be considered today extremely risky, projects. Interestingly, and in a similar vein, Peter Higgs, who won a Nobel Prize more recently for prediction of the boson which bears his name, said in an interview in the Guardian newspaper that he doubts a similar breakthrough could be achieved in today's academic culture because of the expectations on academics to collaborate and keep churning out papers. He went on to say that it's difficult to imagine how I would ever have enough peace and quiet in the present sort of climate to do what I did in 1964. Such immense figures in science are not wrong in their assertions, and there are few career scientists in the academic world today who would disagree with these sentiments. Maybe one of the reasons why so many Nobel Prize-winning scientists are critical of the subjectivity of the peer review system is that, in their early careers, papers describing their initial award-winning discoveries were rejected by their peers. These rejected laureates include Orn Wilhelm Korin Tiselius, 1948, Chemistry, Hideki Yukawa, 1949, Physics, Hans Adolf Krebs, 1953, Physiology, Medicine, John Bardeen, 1956, Physics, Pavel Alexievich, Ilya Mikhailovich Frank and Igor Yevgenyevich Tam, 1958, Physics, Arthur Kornberg and Severo Ochoa, 1959. Physiology, Medicine, Frank McFarlane Burnett, 1960, Physiology, Medicine, Eugene Paul Weiner, 1963, Physics, Murray Gell-Mann, 1969, Physics, John Bardeen, 1972, Physics, Baruch Samuel Bloomberg, 1976, Physiology, Medicine, William Nunn Lipscomb, 1976, Chemistry, Rosalind Yallow, 1977, Physiology, Medicine, Herbert Charles Brown, 1979, Chemistry, Henry Taube, 1983, Chemistry, John Charles Polanyi, 1986, Chemistry, Gerd Binnig and Heinrich Rohrer, 1986, Physics, Stanley Cohen. 1986, Physiology, Medicine, Harbert Michel, 1988, Chemistry, Richard Robert Ernst, 1991, Chemistry, Michael Smith and Carrie Banks Mullis, 1993, Chemistry, Martin Rodbell, 1994, Physiology, Medicine, David Morris Lee, Douglas Dean Arsharoff, Robert Coleman Richardson, 1996, Physics, Paul Delos Boyer, 1997, Chemistry, Robert Francis Furchgott and Louis J. Ignarro, 1998, Physiology, Medicine, Gunther Blobel, 1999, Physiology, Medicine, Herbert Kromer, 2000, Physics. As can be seen from that list, the rejection of papers by well-known and highly respected scientific journals is not discipline-specific. There has thus been a most fundamental and dramatic climate change in academic science over the past decades, one of such a magnitude and severity that the innovators in our global society are finding it hard to flourish or even just survive. How has this happened, and why have we let it happen? One of the most obvious reasons for this lies in the commercialization of academic institutions. Few academics would deny that institutions cannot run at a loss, but the drive today is to maximize profits. To this end, the bureaucracy within universities has mushroomed, and the old view of administrators as support staff for academics has now been effectively reversed. Many academics now regard themselves as no more than cash cows for a burgeoning administration who top-slice research grants for their own needs and who, having been given the powers to do so, set the agendas for academic appraisals, including sums to be obtained externally for each academic grade, numbers of postgraduate students to be supervised, and number and quality of peer-reviewed articles to be published. Actually, in some academic systems, such as that of the UK, the number of quality publications is not an important aspect of academic assessment as long as each tenured academic has published the minimum number required, usually 3 to 5, in periodic, 5-year, central government assessments of research productivity. Failure to produce the requisite number of such publications can have detrimental effects on an academic's ability to pursue their chosen research, or much worse. The fact that peer review is a fundamental aspect of both publishing articles and obtaining external research income necessitates a more detailed analysis. Sidney Brenner said of peer review. And of course all academics say we've got to have peer review. But I don't believe in peer review because I think it's very distorted and as I've said, it's simply a regression to the mean. I think peer review is hindering science. In fact, I think it has become a completely corrupt system. It's corrupt in many ways, in that scientists and academics have handed over to the editors of these journals the ability to make judgment on science and scientists. There are universities in America, and I've heard from many committees, that won't consider people's publications in low impact factor journals. Now I mean, people are trying to do something, but I think it's not publish or perish, it's publish in the okay places, or perish. And this has assembled a most ridiculous group of people. I wrote a column for many years in the 90s, in a journal called Current Biology. In one article, Hard Cases, I campaigned against this culture because I think it is not only bad, it's corrupt. In other words, it puts the judgment in the hands of people who really have no reason to exercise judgment at all. And that's all been done in the aid of commerce, because they are now giant organizations making money out of it. There are various descriptors used when discussing scientific publication, and it would be useful to look at the meaning of these in more detail. High impact factor journals. Impact factors for scientific journals are a relatively recent arrival on the publishing scene and provide the administrators in academic institutions with a numeric score for the quality of a given publication, or do they? Such factors result from assessing a range of parameters such as number of citations and the time decay rates of citations, but they are mean values given for journals, not for individual articles in the journals. So two papers published in the same journal may have radically different individual scores. The scenario has indeed occurred, where an individual paper in a high-impact journal may have a lower impact score than a paper published in a lower-impact journal. Some journals have lower impact scores due to their highly specialized discipline focus, while others have higher impact scores due to their more generalized nature. It has been noted that some high-impact factor journals that become more selective of the papers they accept actually force contributors to send their papers to lower-impact factor journals. Ironically, over relatively short time periods, impact factors are reviewed annually. Some of the former journals become lower in impact factor, while the latter ones increase. Thus impact factors are not in reality an indicator of the quality of individual papers, and such factors can change over short periods of time. Unfortunately, impact factors are now widely used by university bureaucracies as a metric of the worth and reputation of the academic output of individual scientists, which brings an observation of Albert Einstein to mind: not everything that can be counted counts, and not everything that counts can be counted. A mentor of mine who was a senior professor in the National Institutes of Health and a member of the National Academy of Sciences in the United States was most dismissive of impact factors as a measure of publication quality. As a distinguished chemist and pharmacologist, he often said that, for most of his career, he published in the most appropriate journals for his work to be read by the most appropriate people, his research peers. These were also the most appropriate people to gauge the relative impact and importance of his work. Peer review. The definition of peer review previously given would seem quite reasonable to most people: review of a scientific manuscript by a small number of scientists working in the same field as the subject matter of the submitted work, objectively assessing its quality. However, for some journals this does not happen, as decisions on whether to publish are often made by an editor or a sub-editor, with rejection letters usually containing phrases referring to their large numbers of submissions, lack of space in their journal, and a suggestion that one send the manuscript to a more specialized journal. Most often, however, upon submission, authors are requested to name several potential reviewers, and sometimes to name individuals that one would not wish to review the paper, and then the editor reserves the right to use some or all of the suggested reviewers or to choose their own. Most commonly, editors will use a minimum of 3 reviewers for each submission. In the world of professional scientists, just as in any other sphere of life, there are people one can get along with and others one cannot, so authors would tend to choose their friendly colleagues as reviewers and not their known professional rivals. However, sometimes most of one's peers in a given area of scientific research are one's rivals, especially if they are within the same academic system, country, and are competing for the same funds for similar research. Can such peers really be totally objective in assessing a rival's application? Over many years of publishing scientific papers, a productive author can develop skills in identifying the sources of reviews by use of a number of clues in writing style and word usage. Sometimes such reviews contain clearly subjective statements in the equally clear absence of objective points, indicating a reviewer's obvious reluctance to see the submission published. Editorial decisions to accept or reject a submitted paper, following review, will take into account the consensus among the 3 reviewers used, or, when contentious, the editor may use additional reviewers or make a decision personally. However, one often sees reviews written by individuals who obviously are not familiar with the subject matter or who make statements that are factually incorrect. In the past, most editors afforded a right of reply for such anomalies, but this has become increasingly rare in today's publication climate. The peer review system for academic publication, as currently constituted, thus rejects some papers that are scientifically valid and, conversely, accepts some that are not. Some, but not all, of the latter may subsequently be retracted, and some of the former may never appear on the printed page. Critics of non-mainstream robust scientific findings often cite the fact that these have not been subjected to peer-reviewed publication, but surely it is clear that this argument is facile. Many of the so-called modern gurus of science disseminate their often outrageous and untested pseudoscientific dogma in the popular press, and it is becoming increasingly obvious that the public are unwittingly influenced by such, believing this to be authentic scientific fact. On the other hand, the current system of peer review both in funding for research and in publication of papers is highly focused on maintaining the status quo and is often highly dismissive of genuine ideas and novel findings. This has been and continues to be the experience of many innovative scientists, including most Nobel laureates. Note, again, our long list of rejected laureates. Although it is clear that the peer review process is highly subjective in many aspects, many authors have wondered whether actual bias exists in the process. The answer is yes, with elements of both sexism and nepotism having been found. There is strong evidence of bias against women applicants in the awarding of research grants, as well as a bias toward favorable outcomes for submissions based on well-known authors in the author list and/or the level of prestige of the institutions in which the research was performed. There may also be bias depending on the country in which the research has been performed and on whether the paper contains negative results which either relate to a new study or demonstrate a failure to replicate a study that has been previously published, especially in the same journal. The more sinister side to the process is that reviewers may steal the submitting author's ideas to present them as their own at a later date and/or may delay publication if their own research group is working on the same or similar questions. Editors and editorial boards, reviewers, are constituted either by members of specific learned societies and/or by scientists working in the same or related discipline, and, by inference, these individuals are working and competing in similar if not identical areas. Traditionally, research journals were managed by specific learned societies, and latterly by publishing houses, and in both cases, funding to produce these journals, and sometimes associated profits, were made through subscriptions for access by university libraries, less often by individuals. However, in more recent years, the trend in scientific publishing has gravitated toward so-called open access, driven initially by a desire for public purse funding agencies to see the results of their funded research being made available to the general public. This aspiration, on the face of it, is good, but it comes at a substantial cost. Most such funding agencies provide finance for open access publishing, or if not, this is supplied by special funds in universities. The costs of this process to funding donors, university hosts, and the profits to be made by publishers, are not trivial, and there has thus been a veritable explosion in the numbers of open access journals and of established journals who now offer such an alternative service. While some open access journals began their lives as high impact factor, highly selective, quality journals, many have now become repositories for the mundane, as the huge profits to be made have been realized. The peer review process occurs much as before, but the approach to this has become somewhat soft-handed, with the academic reviewers often not being specialists in the subject matter but still receiving little remuneration for their professional input. A second alarming factor arising from soft-handed review procedures is an increase in the likelihood of publication of fraudulent, misinterpreted, or selective data, which cannot be replicated by the interested reader. Replication of published data by other research groups is a fundamental aspect of validation in research and often uncovers such malpractices. To the surprise of many outside the field of scientific research, such errant behaviors are not unusual. In a featured article in The New Scientist, Sonia Van Gilder Cook wrote, "Listening to When I'm 64 by the Beatles can make you younger. This miraculous effect, dubbed chronological rejuvenation, was revealed in the journal Psychological Science in 2011. It wasn't a hoax, but you'd be right to be suspicious." The aim was to show how easy it is to generate statistical evidence for pretty much anything, simply by picking and choosing methods and data in ways that researchers do every day. The paper caused a stir among psychologists, and has become the most cited in the journal's history. The following year, Nobel Prize-winning psychologist, Daniel Kahneman, stoked the fire with an open email to social psychologists warning of a train wreck if they didn't clean up their act. But things only came to a head last year with the publication of a paper in Science. It described a major effort to replicate 100 psychology experiments published in top journals. The success rate was little more than a third. People began to talk of a crisis in psychology. In fact, the problem extends far beyond psychology. Dubious results are alarmingly common in many fields of science. Worryingly, they seem to be especially shaky in areas that have a direct bearing on human well-being, the science underpinning everyday political, economic, and healthcare decisions. No wonder the whistleblowers are urgently trying to investigate why it's happening, how big the problem is, and what can be done to fix it. Fiona Godley concluded, in a study of peer review, that it does not do well at detecting innovative research or filtering out fraudulent, plagiarized, or redundant publication. Perhaps the most disturbing conclusion was that the process often fails in detecting the innovative. In his conclusion to an article titled Peer Review, a Flawed Process at the Heart of Science and Journals, published in the Journal of the Royal Society of Medicine, Richard Smith, Chief Executive of United Health Europe, stated, "So peer review is a flawed process, full of easily identified defects with little evidence that it works. Nevertheless, it is likely to remain central to science and journals because there is no obvious alternative, and scientists and editors have a continuing belief in peer review. How that science should be rooted in belief." Summary and closing thoughts. Science is widely regarded as a totally objective means of establishing a contemporary worldview as an alternative to the faith-based worldview described in the Bible. Put simply, science often claims that so-called scientific facts produce a superior interpretation of the reasons for the existence of the universe and its component subatomic particles, and for the appearance of life and its component biomolecules and its gradual evolution into multiple and diverse forms. However, science is not omniscient, and it is subject to regular and often dramatic revelations that concepts once regarded as absolute truth are not. The origins of the universe and of life itself have not been proven scientifically, and still today represent major unanswered questions, although this reality is often not stated in open debate or indeed in school textbooks. So many of the fundamental dogmas associated with scientism are held by faith or, to use a more appropriate scientific term, speculation. The so-called scientific dogma pertaining to the origins of the universe and of life do not in themselves fulfill one of the essential attributes of the scientific process, that is, having firm and testable evidence. Anything less is thus a faith-based system, which may come as a revelation to many. A second revelation we have seen is that science itself, and virtually all of its component machinery, is subject to bias. Young aspiring research scientists have to undergo a long period of study and training and may, if fortunate, secure a tenured or tenure-track position in their early to mid-30s, having invested much time and financial resources and often having personal and social commitments that can affect the objectivity of their work. Under such circumstances, they may have little interest in challenging the scientific establishment. In times past, once a tenured position was secured, the researcher was essentially free to pursue new ideas that would challenge accepted dogma without fear of dismissal, but in more recent times this contractual provision has all but vanished from academia. In many institutions, academics are now subjected to regular appraisals by the administration to evaluate their progress through analysis of key performance indicators, and failure to meet such arbitrary criteria can result in failure to progress through salary scales and obtain promotions, and can ultimately result in dismissal from employment in one's chosen field. A research scientist's performance is often defined by things such as quantity and source of external research funding, number and quality of peer-reviewed publications, and number of postgraduate research students under his or her supervision. For some researchers with significant undergraduate teaching time, there will also be assessment of student feedback. The academic thus has to spend much time writing funding applications and publications, supervising research students, and preparing and delivering lectures. Career research scientists thus have to abide by certain rules of engagement if they wish to be successful in this highly competitive environment, and challenging establishment dogma or practices in their respective chosen fields would be detrimental to smooth and rapid advancement. This is one of the main reasons why many of them remain silent silent or guarded in their speech and writing during their employment, choosing to toe the party line. However, upon retirement and/or after a major award such as a Nobel Prize, many scientists are free to speak openly about the state of bias and the problems in science, as is the case with some of the authors cited in this chapter. Perhaps this chapter can best be summarized by an article written by Lee Smolin, published in Physics Today and titled "Why No New Einstein," in which he analyzes the position of innovative and independent thinking scientists in what he calls the hostile environment which they currently inhabit. He writes, "Those who follow large well-supported research programs have lots of powerful senior scientists to promote their careers. Those who invent their own research programs usually lack such support and hence are often undervalued and underappreciated. People with the uncanny ability to ask new questions or recognize unexamined assumptions, or who are able to take ideas from one field and apply them to another, are often at a disadvantage when the goal is to hire the best person in a given well-established area. In the present system, scientists feel lots of pressure to follow established research programs led by powerful senior scientists. Those who choose to follow their own programs understand that their career prospects will be harmed. That there are still those with the courage to go their own way is underappreciated. It is easy to write many papers when you continue to apply well-understood techniques. People who develop their own ideas have to work harder for each result because they are simultaneously developing new ideas and the techniques to explore them. Hence they often publish fewer papers, and their papers are cited less frequently than those that contribute to something hundreds of people are doing. It is thus evident that the current system of funding, review, and publication of scientific research, rather than facilitating those with brilliant, innovative, and questioning minds, serves to make their work more difficult and demanding than that of their compliant peers. Perhaps this is one of the reasons why the current research literature is composed predominantly of incremental studies on previously revolutionary scientific discoveries and not with those of a game-changing nature. In view of the fact that scientific research currently receives considerably more funding than at any time in human history, the scientific establishment urgently requires a revolution in its operational practices to eliminate the numerous points in its procedures at which bias in all its forms takes place. It is not good enough for the establishment to say that the systems of academic appointments, promotions, evaluation, and peer review of grants and publications are flawed but are the best that we have. It is also unacceptable that research themes and funding initiatives should be set by politicians and administrators, and that what appears in published form should be the final decision of journal editors. Science agendas need to be set by scientists themselves, and freedom of thought and the generation of diverse ideas should be the main drivers in these processes. To paraphrase Albert Einstein, the problems we face today cannot be solved by the minds that created them. Section 2. The Philosophical Critique of Theistic Evolution. 18. Why Science Needs Philosophy. J. P. Moreland. Summary. We shall explore two philosophical theses from philosopher George Beeler that illuminate ways in which philosophy is relevant to science, especially to the debate about theistic evolution versus intelligent design. The autonomy of philosophy, among the central questions of philosophy that can be answered by one standard theoretical means or another, most can in principle be answered by philosophical investigation and argument without relying substantively on the sciences. The authority of philosophy, insofar as science and philosophy purport to answer the same central philosophical questions, in most cases the support that science could in principle provide for those answers is not as strong as that which philosophy could in principle provide for its answers. So, should there be conflicts, the authority of philosophy in most cases can be greater in principle. See below for attribution. The autonomy of philosophy refers to areas of philosophical investigation that lie completely outside the competence of science. The authority of philosophy refers to areas which both science and philosophy investigate, where the philosophical factors carry more weight than and trump those of science. I list key examples of both that are relevant to setting the intellectual context for debating the relative merits of theistic evolution versus intelligent design. People sometimes ask, what does Athens, reason, have to do with Jerusalem, faith? The implied answer is usually nothing. In my view, the correct answer is plenty, but I cannot defend that claim here. Similarly, many people, especially many, maybe most, scientists ask, what does philosophy, idle speculation, have to do with science, which which secures hard facts about reality? Again, the usual answer is nothing. But nothing could be further from the truth. Science and philosophy have interacted and do interact with each other in a number of ways that, in the normal course of science education and practice, are sadly not made available to scientists themselves. In this introduction to Section 2, the philosophical critique of theistic evolution, I shall focus on two philosophical theses that illuminate ways in which philosophy is relevant to science, especially to the debate about theistic evolution versus intelligent design. Here are the two theses, stated clearly by philosopher George Beeler. I wish to recommend two theses. 1. The autonomy of philosophy, among the central questions of philosophy that can be answered by one standard theoretical means or another, most can in principle be answered by philosophical investigation and argument without relying substantively on the sciences. 2. The authority of philosophy, insofar as science and philosophy purport to answer the same central philosophical questions, in most cases the support that science could in principle provide for those answers is not as strong as that which philosophy could in principle provide for its answers. So, should there be conflicts, the authority of philosophy in most cases can be greater in principle. To illustrate briefly, the autonomy of philosophy refers to areas of philosophical investigation, example, debates about abstract objects, different interpretations of modal logic, the relative merits of utilitarian versus virtue ethics, that lie completely outside the competence of science. The authority of philosophy refers to areas which both science and philosophy investigate, example, the nature of time, the question of whether unobservable theoretical entities of scientific theories exist or are useful fictions, where the philosophical factors carry more weight than and trump those of science. In what follows, I shall list key examples of both that are relevant to setting the intellectual context for debating the relative merits of theistic evolution versus intelligent design, starting with the principle of authority. Examples of the principle of authority. Example 1, Stephen Hawking on the beginning of the universe. In the past few decades, there has been a stunning revival of an argument for God's existence from the fact that the universe had a beginning. The argument, called the Kalam cosmological argument, is, in fact, many centuries old, but it has been given new strength and clarity in recent times. For our purposes, there are four arguments for the universe's having a beginning: the impossibility of an actual infinite set of concrete entities such as events, the impossibility of traversing an actual infinite series of events by successive addition, the standard Big Bang model, and the second law of thermodynamics. Most of those who say that the universe did have a beginning hold the first two, philosophical, arguments to carry more weight than the last two, scientific, arguments and, thus, on the assumption that arguments for and against this claim are themselves philosophical, this seems to be a clear example of the authority thesis, that philosophy carries more weight than science. In his book A Brief History of Time, Hawking develops a no-boundary model of the beginning of the universe, and he uses imaginary time, example, multiples of the square root of -1, to avoid a cosmological singularity, an absolute beginning, to retain a finite past, and to depict the initial segment of spacetime as rounded off very much like the South Pole being the beginning of the Earth and various circles of latitude playing the role of time itself. Just as you cannot ask what is south of the South Pole, you cannot ask what was before the rounded-off section of the initial segment of space-time. So there is no need for a beginning, yet the past is finite. Philosophers, especially philosophers of science, have responded to Hawking in two ways. First, the philosophical support for the Kalam cosmological argument's first premise, the universe had a beginning, is stronger than the support for Hawking's model, so one should still believe in a beginning. Second, because Hawking's model employs imaginary time, a notion that is literally conceptually unintelligible if taken to depict reality as it really is, the model should be understood in an anti-realist way, example, in an instrumentalist or positivist way, example, as a useful fiction, rather than in a realist way, as an actual depiction of the real world. Hawking admits that his model is nothing but a useful fiction, and that he himself is an anti-realist, a positivist, and an instrumentalist. But these notions are not scientific ones and, in fact, cannot be found in purely scientific writings. Thus, for Hawking to know the meaning of these notions and explicitly identify his views with them, he had to do some reading in the philosophy of science. Why? Because these viewpoints and labels are philosophical in nature, and the field that has developed and debated them is philosophy, not science. So in order for Hawking to express the real implications of his model, he had to turn to philosophy, not to science. As a result, this nicely illustrates the authority of philosophy. This is an odd result, since Hawking claims that philosophy is dead, yet he must turn to philosophy in a foundational way to express how he understands his own model. Thus, it was the discipline of philosophy that both placed Hawking's model in the classification to which it belongs, and continued to show that his model did nothing whatsoever to undermine belief in the universe's beginning. Example 2, Stephen Hawking on the universe coming to be from nothing. In The Grand Design, Hawking and his co-author, Leonard Mlodinow, claim that quantum physics has made the need for a creator and designer superfluous. This is because the universe can create itself, that is, it came into existence out of nothing. This claim upset the faith of a number of believers, because it was the considered judgment of a scientist, indeed, one of the top living scientists. But alas, Hawking and Mlodinow may well be great scientists, but they are very poor philosophers. Why? Because their concept of nothing is not the same as the philosophical one, and the philosophical notion is the relevant one in deciding on the need for a creator. For Hawking and Mlodinow, nothing means a quantum vacuum, which contains energy and is itself located in space. The universe comes into being spontaneously as a fluctuation of the energy in the vacuum. Unfortunately, this is hardly a case of the universe coming into being from nothing. The philosophical notion of nothing is just that, the complete and total lack of any being whatsoever, including the absence of particles, causal powers, fields, properties, and so on. Given this notion of nothing, it becomes self-evident that, necessarily, something cannot come from nothing without a cause, because there is nothing to come from. The Hawking-Mlodinow claim reminds me of a joke. A group of scientists come up to God and tell him that they don't need him anymore because they can now create life. So God asks them to show him their new discovery. The scientists bend down, scope up some dirt, but before they can go farther, God interrupts them and says, "If you don't mind, get your own dirt." Similarly, if we say that we don't need God anymore because the universe can come from nothing, that is, a quantum vacuum, then the proper response from God would be, "If you don't mind, get your own quantum vacuum." In this example, the philosophical considerations carry more weight than do the scientific claims. Example 3, the origin of life. There has been a long-running debate as to whether or not we can discover a reasonable, natural scientific explanation for the origin of life without the need for divine intervention or even the discovery of characteristics of life that are best explained by an intelligent designer. And that debate has, for quite some time, centered on scientific considerations, example, the high improbability of chance and natural law doing the job. But some philosophers have resisted the notion of a purely naturalistic, physicalistic account of life's origin. To begin with, it has been very difficult for biologists to define life. As origin of life researcher Antonio Lozcano notes, life is like music, you can describe it but not define it. According to Fazali Rana, biologists have collected a list of around 100 different definitions of life. According to biologists, some of the essential characteristics of life include biological stability, permanence, and coherence, being made of atoms, molecules, and cells that obey the laws of chemistry and physics, being composed of a highly structured homeostatic nature, being able to ingest nutrition, expel waste, and reproduce. But scientific or biological attempts to define or provide essential characteristics of life flounder because, as many philosophers have pointed out, life is a univocal, projectable predicate. What does this mean? First, the term life is something we predicate of certain things and not others. Second, life is univocal and not equivocal, that is, it means the same thing whenever we employ it. Thus, to say a dog or a human or a fish is alive is to use the term life in the same way. Different living things may live in different ways and sustain their lives by employing different factors, but they are all living. We don't have one definition of life for a dog, one for a human, and one for a fish. If we did, life would be an unwieldy predicate of which we would have no understanding when we applied it to a newly discovered creature. Finally, life is projectable. While we start out by using the term life for living things with which we are acquainted, we can also use the term for yet to be discovered actual or possible living things, example, life in outer space, unicorns. But now a problem arises for biological attempts to define or essentially characterize life. Life is univocally predicable of disembodied souls after death, of angels, and of God himself. Even if none of these things exist, their existence is coherent and intelligible, and the projection of life into possibly living things should be univocal. But none of these entities satisfy physical, biological characteristics for life. Thus, life itself cannot be physical, so the argument goes, and there will never be a strictly scientific account of life or its origin. To get life from rearranging matter is to get something, life, which is not physical, from nothing, brute matter that does not have life. Interestingly, many philosophers have provided new evidence for this argument by claiming, following biologists, that living things are constituted by information. But apart from a few exceptions, many, perhaps most philosophers who work in this area have claimed that information is immaterial, more fundamental to reality than matter, and, given its nature, there can be no material explanation for the origin of immaterial information and, thus, for the origin of life. 7. 2. Examples of the principle of autonomy. Example 1. The nature and existence of consciousness and the soul. I doubt that any list of the proper issues within a sub-branch of philosophy would be complete. Still, it is possible to provide a reasonably adequate characterization of the central first-order topics that are ubiquitous in the literature in philosophy of mind. Those topics tend to revolve around 4 interrelated families of issues, constituted by the following kinds of representative questions. Ontological questions. To what is a mental or physical property identical? To what is a mental or physical event identical? To what is the owner of mental properties, events identical? What is a human person? How are mental properties related to mental events? Example, do the latter exemplify or realize the former? Are there Aristotelian or Leibnizian essences, and, if so, what is the essence of a mental event or of a human person? Epistemological questions. How do we come to have knowledge or justified beliefs about other minds and about our own minds? Is there a proper epistemic order to first-person knowledge of one's own mind and third-person knowledge of other minds? That is, does the information we gain from our own first-person perspective about our own conscious states and our own self have rational authority over third-person attempts by others to gain such knowledge, or is it the other way around? How reliable is first-person introspection, and what is its nature? Example, is it an experimental seeming, or a disposition to believe? If the former, then experience of one's mental state, example, an awareness of the hurtfulness of a pain, is prior to the tendency to believe that a pain hurts. In this case, one has to admit that experimental states of consciousness, seeming states, are real and cannot be reduced to a belief, which can be reduced further to linguistic behavior, example, the ability to use the word pain correctly, an ability that an unconscious computer could possess. If first-person introspection is reliable, should it be limited to providing knowledge of consciousness, or should it also include knowledge about one's own ego? Why worry about such issues? The answer is this: when we are trying to gain authoritative knowledge about consciousness, if the first-person perspective is of primary importance, then one will take consciousness to be what one experiences in introspection, and this supports the non-physical nature of consciousness. However, if one takes the third-person perspective to have priority, then scientific claims about the brain will have more authority than introspective claims offered from the first-person point of view, and this pecking order will support physicalist reductions of consciousness to brain states. Semantic questions. What is a meaning? What is a linguistic entity, and how is it related to a meaning? Is thought reducible to or a necessary condition for language use? How do the terms in our common-sense psychological vocabulary get their meaning? The main second-order topics in philosophy of mind revolve around a fourth set of representative questions. Methodological questions. How should one proceed in analyzing and resolving the first-order issues that constitute the philosophy of mind? What is the proper order between philosophy and science? Should we adopt some form of philosophical naturalism, set aside so-called first philosophy, and engage topics in philosophy of mind within a framework of our empirically best-attested theories relevant to those topics? What is the role of thought experiments in philosophy of mind, and how does the first-person point of view factor into generating the materials for formulating those thought experiments? These are the sorts of questions that form the warp and woof of philosophy of mind. Please read the list carefully. It becomes evident that these are in no way scientific questions, they are philosophical to the core and nicely illustrate the autonomy thesis. But, you may respond, as Nancy Murphy has, science has provided a massive amount of evidence suggesting that we need not postulate the existence of an entity such as a soul or mind in order to explain life and consciousness. This evidence consists of the fact that biology, neuroscience, and cognitive science have provided accounts of the dependence on physical processes of specific faculties once attributed to the soul. I offer two responses, the first stated nicely by Steve Evans regarding the findings of localization studies. What, exactly, is it about these findings that are supposed to create problems for dualism? Is it a problem that the causal effects should be the product of specific regions of the brain? Why should the fact that the source of the effects are localized regions of the brain, rather than the brain as a whole, be a problem for the dualist? It is hard for me to see why dualism should be thought to entail that the causal dependence of the mind on the brain should only stem from holistic states of the brain rather than more localized happenings. Second, all neuroscience can do is establish precise, brute correlations, causal relations, or dependency relations between mental and physical states. It can tell us nothing about the intrinsic nature of consciousness or whether or not there is a soul. These are philosophical questions. To see this, consider the discovery that if one's mirror neurons are damaged, then one cannot feel empathy for another. How are we to explain this? 3 empirically equivalent solutions consistent with all and only the same set of observations, come to mind. 1. Strict physicalism, a feeling of empathy is identical to the firings of mirror neurons. 2. Mere property dualism, a feeling of empathy is an irreducible state of consciousness in the brain whose obtaining depends on the firing of mirror neurons. 3. Substance dualism, a feeling of empathy is an irreducible state of consciousness in the soul whose obtaining depends, while embodied, on the firing of mirror neurons. No empirical datum can pick out which of these 3 is correct, nor does an appeal to epistemic simplicity help. Epistemic simplicity is a tiebreaker, and the substance dualist will insist that the arguments and evidence for substance dualism are better than those for the other 2 options mentioned above. Example 2, methodological naturalism, agent causation, and the nature of science. When it comes to the task of defining or giving the essential characteristics of science, that task belongs to philosophers and historians of science, and not to scientists themselves. Perhaps the main philosophical issue in the theistic evolution intelligent design dialogue involves the appropriateness of using science to warrant the inference to an intelligent cause for some phenomenon. Central to this dialogue is the question of whether or not science must adopt methodological naturalism, roughly the idea that, while doing science, one must seek only natural causes explanations for scientific data. There has been some controversy as to which field is the proper place to turn to in order to seek professional expertise in resolving this debate. Nor is the question of professional expertise merely an academic matter of turf protection, because, currently, it is largely scientists and science educators who are the gatekeepers for the public schools in this area. That there is a controversy can be seen from this statement by J. W. Haas Jr., former editor of the influential Perspectives on Science and Christian Faith. The place of the philosopher in the practice of science has long been controversial. Whether philosophers can be the arbiters of what constitutes science remains problematic for the working scientist. Along similar lines, scientist Carl Giberson rejects the traditional viewpoint that practicing scientists find so annoying, namely that philosophers are the relevant, competent and final authorities to determine the rules of science. Actually, the issue here is not controversial at all, since the central topics do not involve how to practice science, which requires familiarity with instrumentation, procedures, etc., but how to define science and distinguish it from non-science or pseudoscience. To understand this debate and the proper field of study for resolving it, we must first make a distinction between a first and a second-order issue. A first-order issue is a topic of science about some phenomenon, example, how to predict earthquakes or manipulate chemical reaction rates. A second-order issue is a topic of philosophy about science itself, example, its methods, its nature, its differences from other fields. Now the question of how to define science is clearly a topic for philosophers and historians of science. This is not to say that scientists and others cannot be a part of this discussion, it is merely to affirm that when they participate, they will be largely dealing with philosophical issues for which they are not professionally trained. The fact that these issues are philosophical and not primarily scientific can be seen from the following: read the relevant debates and discussions and ask what scientific experiment, what scientific procedure one would use to resolve the dispute about the nature, proper definition, and limits of science. Or get any college catalog and look at the course descriptions in different branches of science. You will discover that almost nowhere in an undergraduate or graduate program in any branch of science are the relevant topics discussed, except perhaps in the first week of freshman chemistry. By contrast, entire graduate study programs in the history or philosophy of science are devoted to definitions of science and to drawing lines of demarcation between science and other fields. What is the relevance of the authority of philosophy and autonomy of philosophy theses and the illustrations of both in this introduction and in the chapters in this section to follow? The answer is at least twofold. First, a very well-known Christian philosopher recently noted that when scientists make claims that seem to conflict with biblical teaching and solid theology, with notable exceptions, including the biblical scholars and theologians who contribute to this volume, theologians and biblical scholars start ducking into foxholes, hoist the white flag of surrender, and trip over each other in the race to see who can be first to come up with a revision of biblical teaching that placates the scientists. Thus, the dialogue between science and theology or biblical exegesis is really a monologue, with theologians asking scientists what the latest discoveries allow them to teach. Homosexuality is caused by our DNA? No problem. The Bible doesn't teach the immorality of homosexuality anyway, we have misread it for 2,000 years. Neuroscience shows there is no soul? No problem. Dualism and the soul are Greek ideas not found in the Bible, which is more Hebraic and holistic. A completely naturalistic story of evolution is adequate to explain the origin and development of all life? No problem. After all, the Bible isn't a science text. Adam and Eve? Do we really need them? Literally to be historical figures? No. And on it goes. Lest you think I exaggerate, listen to the views of the late theologian Arthur Peacock. Here is a strong prima facie case for re-examining the claimed cognitive content of Christian theology in the light of the new knowledge derivable from the sciences. If such an exercise is not continually undertaken, theology will operate in a cultural ghetto quite cut off from most of those in Western cultures who have good grounds for thinking that science describes what is going on in the processes of the world at all levels. The turbulent history of the relation of science and theology bears witness to the impossibility of theology seeking a peaceful haven, protected from the sciences of its times, if it is going to be believable. Wow! What robust and vibrant confidence in the Bible! The truth is, when Peacock, Giberson, and others make statements like this, for the statements to be credible they need to be expressions of a fairly thorough acquaintance with epistemology. After all, if one is going to claim that one field, science, is cognitively superior to another field, biblical studies, theology, one should have a pretty good idea of what knowledge is and how one can tell the difference between weakly and strongly justified beliefs. This leads me to my second observation about the relevance of the authority and autonomy theses for this book. Scientists are usually ill-equipped to draw metaphysical, epistemological, or moral conclusions from scientific data. And the reason is that drawing those conclusions is largely a philosophical matter, as I have tried to illustrate above. If this is correct, then an issue arises: if some alleged scientific discovery seems to contradict a time-tested understanding of the Bible, and if it contradicts historically embraced and epistemically justified theological models, then why jump immediately to a revisionist view of the Bible and theology? Instead, folks like those involved in biologos should slow down, take a deep breath, and form integrative teams with philosophers, theologians, and scientists who can present rigorous defenses of the tradition Christian positions. This approach is especially incumbent on scientists when they realize that 1. Formulating models of things like the existence of Adam and Eve or the adequacy of naturalistic mechanisms to explain life and its diversity is an integrative affair that should include philosophers and theologians who are able to defend the traditional view, and 2. There is at least a small, or large, but robust group of significant, intellectually rigorous scientists, philosophers, and theologians who are quite competent to defend the traditional view. Such a group exists, though it is far from small, and it is the intelligent design movement. If these two admonitions are followed, then it will become evident that philosophy, especially the authority and autonomy theses, are at the very heart of the issues. In one way or another, all the chapters in this section illustrate the centrality of philosophical issues in the intelligent design, theistic evolution debate. And after reading these chapters, I believe it will become clear that the crucial philosophical issues and arguments to follow show beyond a reasonable doubt that intelligent design theory is far more reasonable than theistic evolution. 19. Should theistic evolution depend on methodological naturalism? Stephen C. Meyer and Paul A. Nelson. Summary. Nearly all theistic evolutionists say that some naturalistic process will eventually explain the origin of novel forms of life. They do so because they accept a philosophical rule known as methodological naturalism. Methodological naturalism asserts that, to qualify as scientific, a theory must explain by strictly physical or material, that is, non-intelligent or non-purposive, causes. This chapter shows that, as a supposedly neutral rule for how science should function, methodological naturalism fails. Nor can one rely on demarcation criteria devised to define science normatively. These criteria, which purport to distinguish science from pseudoscience or religion, die by 1,000 counterexamples. The history of science includes many theories violating one or another allegedly necessary demarcation criterion, such as observability, explanation by natural law, or falsifiability, yet such theories have figured centrally in the development of their respective sciences. Moreover, demarcation criteria cannot justify methodological naturalism itself. Naturalistic evolutionary theories and competing theories of intelligent design or creation either equivalently satisfy demarcation criteria, or fail to do so. The truth about the history of life on Earth cannot be decided by philosophical definitions. Given that no sound justification exists for holding methodological naturalism as a science-defining rule, Christians should not use it as a reason for adopting theistic evolution, or excluding other theories. Introduction, making the rules and playing the game. A young basketball fan today, say, a 10-year-old boy growing up in San Jose, California, who religiously follows the Golden State Warriors and their star Stephen Curry, might be astonished to learn that the three-point shot wasn't always allowed in the NBA. It simply did not exist. But older basketball fans, such as the authors of this chapter, remember the game before 1979, when the three-point shot was first introduced. No three-pointers back then. A field goal from anywhere on the court yielded 2 points. Imagine yourself as an NBA executive in 1979, the rookie season for both Magic Johnson and Larry Bird. You are seated in a conference room, discussing the rule change that will allow three-point shots. You cannot envision that an entire strategy will develop around what happens when an arc is placed on the court, 23 feet and 9 inches from the hoop, at or beyond which 3 points will be awarded to a successful shooter. You just want to make the game more interesting, so you raise your hand to endorse the new rule. Now, were you playing basketball when you voted for the three-point shot? Of course not. The games themselves will take place in wholly different venues, under circumstances that bear no resemblance to discussing rule changes in an executive suite. But your rule-making decisions will affect the future of basketball, and indeed, its very nature, namely, how the game will be played, what skills will be valued, how teams will construct their strategies, and so forth. Let us draw a parallel. While making the rules of science is not the same thing as playing the game of science, that is, actually conducting research, rule-making influences the practice and content of science, shaping what it will be as an enterprise and a body of knowledge, including what kinds of hypotheses its practitioners will permit themselves to consider. Science is something we humans invent and do, it has not been delivered to us, and we devise its rules, methods, and conventions. Moreover, the rules of science can change, because over the course of history, they have changed. But when might a rule need to be changed? In sports, rule changes usually occur when the quality of competition has stagnated or declined. Science is not a game in that exact sense, of course, but metrics of the success or failure of scientific theories exist, and we can ask the same questions, at a deeper level, about scientific methodology itself. Science should be interested in determining the truth, writes Caltech physicist Sean Carroll, whatever that truth may be natural, supernatural, or otherwise. If truth is the ultimate goal of scientific investigation, then any rule that may keep us from reaching that goal needs the closest critical scrutiny. In this chapter, we shall argue that historical biology, the science concerned with explaining how living things came to be, is long overdue for just such a rule change. More than 150 years after the publication of The Origin of Species, evolutionary theory has stalled out. As the preceding section of this book demonstrates, neither standard neo-Darwinian theory, nor any of the other strictly materialistic theories of evolution recently proposed to supplement, or replace, it, can explain the origin of novel biological form. And yet that was supposed to be evolutionary theory's main job. Many theistic evolutionists readily admit this. Biologist Darrell Falk, for example, the past president and currently senior scholar at BioLogos, a group promoting theistic evolution, acknowledges that neo-Darwinian mechanisms cannot explain the major changes and innovations in the history of life. In his review of a book, Darwin's Doubt, written by one of us, Stephen Meyer, Falk wrote that the book identified one of the great mysteries in evolutionary biology today, namely, the origin of animal form. He observed that this problem has never been addressed by neo-Darwinian theory, and he reflected on his own experiences as a college teacher of evolution, discovering the shortcomings of textbook theory when confronted with explaining the origin of, for example, the first animals. He added that the process of natural selection, important as it may be in certain contexts, is not the driving mechanism of macroevolutionary change, and thus, the mystery of the origin of animal life still awaits a solution. Calling the Cambrian explosion of animal life a big mystery, he also acknowledged that none of the newer evolutionary mechanisms or models adequately explain the origin of novel animal form either. Referring specifically to these post-neo-Darwinian mechanisms, Falk admitted, Stephen Meyer is right, that none of the other models fit the bill in a fully satisfactory manner yet. Yet, despite these candid admissions, Falk remains fully committed to some form of theistic evolution. Why? 2. Methodological naturalism as the ground rule of science. Clearly, Falk's reason for remaining committed to theistic evolution cannot be strictly empirical. Given the currently available scientific evidence, evolutionary theory doesn't work, as Falk concedes. Rather, he remains committed to theistic evolution because of how he understands the rules of science to operate. Like nearly all theistic evolutionists, Falk accepts the rule of methodological naturalism. Methodological naturalism asserts that, to qualify as scientific, a theory must explain all phenomena by reference to purely physical or material, that is, non-intelligent, causes or processes. Or as the National Academy of Sciences explains, methodological naturalism holds that the statements of science must invoke only natural things and processes. The key terms here, of course, are natural, meaning the matter and energy of the physical world, but excluding intelligent causes or conscious mind, and only, a logical modifier that restricts scientific explanation to whatever is natural. As Fuller Seminary philosopher and theistic evolutionist Nancy Murphy observes, methodological naturalism forbids referring to creative intelligence in scientific theories. Because of his commitment to methodological naturalism, Darrell Falk will not consider any theory, such as intelligent design, that invokes creative intelligence. Instead, he waits, into the indefinite future, for the formulation of an adequate, strictly naturalistic evolutionary theory. As he explains, I see no scientific, biblical, or theological reason to expect that an intelligent agent might have acted discreetly or discernibly in the history of life. Natural processes are a manifestation of God's ongoing presence in the universe. The intelligence in which I as a Christian believe, has been built into the system from the beginning, and it is realized through God's ongoing activity which is manifest through the natural laws. Those laws are a description of that which emerges, that which is a result of God's ongoing presence and activity in the universe. I see no biblical, theological, or scientific reason to extend that to extra supernatural boosts along the way. Falk's description of his philosophy and theology of nature is admirably clear. It amounts to the a priori conviction that, during natural history, God acted exclusively through naturalistic or materialistic causes. Hence, we are justified in seeking only such causes to explain all phenomena, including the origin of fundamentally new forms of life, and the information necessary to produce them. His philosophy of nature commits Falk to explaining all of natural history via what philosophers and theologians call secondary causes. But that is just another way of expressing a commitment, perhaps a distinctively Christian commitment, to methodological naturalism. Thus, for Fork and other theistic evolutionists, methodological naturalism compensates for the glaring evidential defects in the scientific case for materialistic evolution, not by demonstrating the creative power of a previously unknown evolutionary mechanism, but simply by ruling out competing ideas such as the theory of intelligent design, or even a divinely guided evolutionary process, where such guidance is empirically detectable. Under methodological naturalism, these theories fall outside what the received norms of scientific inference allow. In that case, a version of theistic evolution that does not involve God actively or discernibly guiding the evolutionary process remains as the only scientifically acceptable theory for theistically minded scientists. In this chapter, we evaluate methodological naturalism, both as a normative rule for doing science and as an extra-evidential philosophical principle justifying theistic evolution. If methodological naturalism turns out to be a well-supported rule for governing the practice of science, then some fully natural process must explain the origin of life, plants, animals, and humans, and no other possibilities need, or should, be considered. Indeed, if methodological naturalism turns out to be sound, then theistic evolutionists may well be justified in holding the view that some fully materialistic mechanism of evolution must have caused new forms of life, even if evidence for the necessary creative power of known evolutionary mechanisms is currently lacking. If methodological naturalism is unsound, however, theistic evolution as a theory will need to stand on its own 2 feet, without any philosophical buttressing. Then, as we evaluate evolutionary theory without the protective philosophical armature of methodological naturalism, we may have to accept that there is no evidence showing that undirected evolutionary mechanisms have the creative power to produce new forms of life, as, in fact, we saw in chapters 1 to 9. In that case, scientists may wish to consider the possibility that a designing or creative intelligence played a discernible and causal role in the history of life. And that such a theory may provide a better explanation than materialistic theories for the origin of biological form and information. After all, shouldn't the evidence, rather than an abstract rule like methodological naturalism, decide the outcome of a scientific investigation? 3. Why methodological naturalism? So why have so many scientists, including many Christians, accepted that scientific explanations must invoke only natural things and processes? Perhaps they are merely following the established conventions of their disciplines, out of respect for the customary rules and practices of science, as those rules have come down to them throughout history. As Nancy Murphy explains, most scientists accept methodological naturalism as an unobjectionable convention because seeking natural causes is just what science does. Science as science seeks naturalistic explanations for all natural processes. Christians and atheists alike must pursue scientific questions in our era without invoking a creator. Anyone who attributes the characteristics of living things to creative intelligence has by definition stepped into the arena of either metaphysics or theology. Yet what determined the placement of the boundary line? For Murphy, the boundary we have today, which, as she notes, excludes creative intelligence or intelligent causation, is just the boundary that we were given by history. For better or worse, we have inherited a view of science as methodologically atheistic. Historical inertia, however, to give the inherited rules view a name, hardly justifies methodological naturalism, if we recall that the goal of science is truth, rather than dutifully following whatever our immediate predecessors did, because they followed whatever their predecessors did. If methodological naturalism were only this type of historically contingent convention, scientists seeking true explanations could ignore the rule, especially if they believe the evidence is best explained by intelligent, rather than strictly material, causes. The search for truth should override any custom or convention. Most defenders of methodological naturalism, however, insist that the rule is more than merely an arbitrary convention or the product of historical inertia. Instead, they insist that methodological naturalism is supported by sound methodological principles, by independent and objective criteria of proper scientific methodology, or what are known as demarcation criteria. Demarcation criteria, such as the idea that scientific theories, 1, must be based on observable data and or 2, must be testable or falsifiable and or 3, must offer explanations based on natural law, purport to distinguish genuine science from pseudoscience, metaphysics, or religion. Defenders of methodological naturalism assert that only a fully naturalistic or materialistic approach to scientific inquiry and explanation allows scientists to meet these standards of good scientific practice. Conversely, they argue that non-materialistic or design-based theories that do invoke creative intelligence do not meet these criteria or standards of method and thus do not qualify as genuine scientific theories or explanations. So let us look closely at these demarcation criteria. Do they provide what is needed, namely, a principled philosophical or methodological reason for supporting methodological naturalism? Do the criteria enable scientists or philosophers to define the practice of science in a normative way? Do the criteria justifiably exclude, a priori, some theories as unscientific or pseudoscientific, that is, irrespective of what the evidence may show? If so, then it may be perfectly justifiable to exclude from scientific consideration theories of the origin and development of life that invoke creative intelligence, and it may also be justifiable to require that theories refer only to materialistic causes or natural processes, just as many theistic evolutionists assume. If methodological naturalism is not well grounded, however, then the rule may be damaging science and limiting the freedom of scientists, indeed, anyone, to seek the truth about how life actually originated, for example. 4. A conversation about methodological naturalism. And what wasn't said. On rare occasions in the life of a student, something so significant happens, in conversation with an older mentor or scholar, that the episode determines the future thinking of that student. Such a conversation happened to one of us, Paul Nelson, in October 1983, when he was still an undergraduate, studying the philosophy of science and evolutionary biology at the University of Pittsburgh. The episode, a discussion about methodological naturalism with the distinguished historian of science Ronald Numbers, is worth recounting, as it illuminates the central problem with methodological naturalism, in particular, with methodological naturalism's putatively objective standing as a ground rule for science. Numbers is a professor of the history of science at the University of Wisconsin and one of the world's leading scholars on the relationship of science and religion. In 1983, he received a fellowship from the Guggenheim Foundation to write a history of American creationism. He had learned that Paul possessed some historically valuable correspondence and papers belonging to his grandfather, Byron C. Nelson, 1893–1972, an influential early 20th century creationist, so Numbers made an appointment to visit Pittsburgh and review the materials. On October 18, 1983, after a morning of reading the letters, Numbers took Paul out to lunch at a local restaurant. At the time, Paul was preparing to write his senior thesis in the philosophy of science, on the topic of intelligent design in biology. He was troubled by a pervasive incongruity in how the empirical possibility of design, i.e., causation by an intelligent agent, had been treated in biology since Darwin's time. For Darwin, design was not only a live possibility but represented the central target of his one long argument in The Origin of Species, 1859. In other words, design might have been true. Darwin thought it was true, in fact, when he set sail on the Beagle in 1831, though he later concluded the evidence spoke against it. I can entertain no doubt, wrote Darwin, that the view which most naturalists entertain, and which I formerly entertained, namely, that each species has been independently created, is erroneous. But whatever can be false, erroneous, in Darwin's words, could by logical symmetry also be true. The evidence should decide, except that methodological naturalism says otherwise. Never mind the evidence, design categorically may not be considered as an empirical possibility. The statements of science, says the National Academy, must invoke only natural things and processes. Over lunch, Paul presented this philosophical incongruity to Numbers. Methodological naturalism seemed arbitrary at best, Paul said. If design can be false, as Darwin argued, then it might also be true. Whatever philosophy of science we adopt, therefore, should allow for both possibilities, letting the evidence determine the outcome, right? Without looking up from his food, Numbers nodded his agreement, but only with the possibility of intelligent design. Of course intelligent design is possible, he replied. But that isn't the issue. Look, he went on, why is it that in baseball, when one hits the ball outside the first or third base lines, i.e., a foul ball, one cannot run to first base? Baseball has its rules, he said, answering his own question. So does science. Since the rise to dominance of scientific materialism in the 19th century, the rules of science have included methodological naturalism. Not every empirical possibility is going to be able to get into the game. That may strike you as unfair, Numbers acknowledged, but that is how the game of science has been played for a long time now, and it's not going to change. If you want to participate, follow the rules, particularly methodological naturalism, or find another game. Well, rules are rules, Paul thought to himself, and if everyone accepts them, one can hardly make a fuss about those rules, at least if one wants to join the game as it is currently being played. But what struck Paul most powerfully at that moment, and what has influenced his thinking ever since, was what Numbers did not say at the lunch table that afternoon. The demarcation criteria work, except when they don't. Numbers did not support methodological naturalism by appealing to any of the familiar and supposedly neutral methodological criteria used to define or demarcate science, such as observability, testability, falsifiability, or explanation by reference to natural law. He didn't even try. And there are good reasons for that. Historians and philosophers of science have long known that attempts to define science by reference to abstract demarcation criteria have failed. In particular, the attempt to define science normatively by such criteria has inevitably died by 1,000 counterexamples. Many highly esteemed theories lack some of the allegedly necessary features of science. Demarcation criteria typically either exclude too much already established science, for instance, forcing one to disqualify as unscientific major works in the development of physics, example, Newton's Principia and his Optics, both of which carry significant theological content and fail to meet specific demarcation criteria, see below, or inadvertently to cut the legs out from undercurrent research fields generally regarded as scientific, such as cosmology, theoretical physics, historical geology, psychology, or even evolutionary biology itself. Theories in these fields often refer to unobservables, thus running afoul of the widely cited requirement that proper theories refer only to observable entities, or fail to make testable or falsifiable predictions or do not explain via natural laws. Or all of the above. The failure of demarcation criteria became a public issue in the immediate wake of a famous court trial that was decided shortly before Nelson's conversation with Numbers. In January 1982, federal judge William Overton overturned an Arkansas law requiring the teaching of creationism alongside evolution in the Arkansas public schools. To justify his ruling in the McLean v. Arkansas case, Overton cited demarcation criteria by which he claimed science could be defined normatively, and against which creationism could be measured to determine whether it qualified as a scientific theory. Overton ruled, basing his judgment on the plaintiff's expert witnesses, that creationism did not qualify as a scientific theory, but was instead an establishment of religion, because it failed to exhibit distinguishing characteristics of a scientific theory, such as, 1. Being guided by natural law, 2. Explaining by reference to natural law, 3. Being testable against the empirical world, 4. Being falsifiable, and others. Within months of the ruling, the adequacy of the McLean criteria, and Overton's use of demarcation criteria generally, had come under blistering attack from philosophers of science, with no sympathies for creationism, incidentally. They explained that many theories throughout the history of science simply could not be described by the McLean criteria, yet those theories were unquestionably scientific, in the critical sense of advancing the growth of empirical knowledge about the natural world. Nor could the criteria be justified philosophically, as defining the norms of science. The philosophers who critiqued the McLean ruling understood firsthand that the demarcation program, a central preoccupation of 20th-century philosophy of science, had failed to find adequate criteria to define scientific theories normatively. In other words, no criteria comprehensively captured the features of science, to the exclusion of metaphysics, theology, or other knowledge claims, such that scientists, philosophers, or federal judges, for that matter, could decide if any theory was scientific without ever examining the relevant empirical evidence. To illustrate the problems associated with using demarcation criteria to judge the scientific status of a theory, consider the second of Judge Overton's criteria, explanation by natural law. Thanks to the expert testimony of philosopher of science Michael Ruse, this criterion featured prominently among the McLean demarcation standards. Nevertheless, writing after the trial, philosopher of science Larry Laudan, an expert on the demarcation problem, could barely restrain his contempt for the dismal inadequacy of the natural law rule. T.O. suggest, as the McLean opinion does repeatedly, that an existence claim is unscientific until we have found the laws on which the alleged phenomenon depends is simply outrageous. Galileo and Newton took themselves to have established the existence of gravitational phenomena, long before anyone was able to give a causal or explanatory account of gravitation. Darwin took himself to have established the existence of natural selection almost a half-century before geneticists were able to lay out the laws of heredity on which natural selection depended. If we took the MacLean opinion criterion seriously, we should have to say that Newton and Darwin were unscientific, and, to take an example from our own time, it would follow that plate tectonics is unscientific because we have not yet identified the laws of physics and chemistry which account for the dynamics of crustal motion. Laudan's observations are telling and insightful. A glance at a historical timeline. For the development of any science, such as geology, shows that the original publication of its laws, such as Nicola Steno's articulation in 1669 of the laws of original horizontality and superposition of strata, requires that those laws first be discovered by someone. Paradoxically, however, the explanation by natural law criterion entails that any research or reasoning activity conducted before geology's laws were discovered and published would ipso facto be unscientific. One cannot explain via a natural law until one knows what that law might be. The criterion thus renders unscientific the many decades or even centuries of unquestionably essential empirical work as sciences have developed and matured. In any case, natural laws are often used to describe, but not to explain, natural phenomena. Newton famously declared that he did not know the cause of universal gravitation, hypotheses non fingo, as he said in Latin. He freely admitted he could not explain what caused gravitational attraction, but instead could only describe the phenomenon mathematically with his law. Thus, a strict application of Judge Overton's second demarcation criterion would, again, imply that Newton's universal law of gravitation, and many other fundamental laws of physics, are unscientific because they do not offer causal explanations for the fundamental physical phenomena they describe. Conversely, many other sciences do offer causal explanations, but they do so, not primarily by citing general laws, but instead by citing past events. Historical sciences, including evolutionary biology, for example, typically explain particular events in the past by citing prior events and conditions that played a causal role in producing the events in question. For example, if a historical geologist seeks to explain what caused the unusual height of the Himalayas, he or she will cite particular events or factors that were present in the case of the Himalayan mountain building episode that were not present in other such episodes. Knowing the laws of physics that describe the forces at work in all mountain building events will not greatly aid the geologist in accounting for the contrast between the height of the Himalayas and all other mountain ranges. To explain what caused the Himalayas to rise to such heights, the geologist does not need to cite a general law but instead needs to give evidence of a distinctive set of past events or conditions. Or consider testability, another key MacLean demarcation criterion. Judge Overton's ruling stated that creationism was not testable, and thus could not be considered scientific. Ironically, just as the criterion of must explain by natural law can be applied in such a way as to render both Newtonian physics and Darwinian biology unscientific, the criterion of testability can be rendered in such a way as to show creationism as a completely scientific research program, quite in opposition to what those using these criteria wanted to show. As Laudan pointed out after the trial, creationists make a wide range of testable assertions about empirical matters of fact. Indeed, in The Origin of Species, Darwin built an evidential case against special creation precisely by testing and finding wanting the special creationist theories of his time. As Ernst Mayr, a leading neo-Darwinian theorist, observed in his 1964 introduction to The Origin of Species, again and again, Darwin describes phenomena that do not fit the creation theory. Consequently, that theory must have been testable and, by the criteria employed by Judge Overton, must be considered scientific. Moreover, the expert witnesses who testified against the Arkansas law in November 1981, including Michael Ruse and Stephen Gould, among others, clearly thought that geological and biological evidence contradicted the claims of the modern young Earth version of creationism discussed at the trial. That version must, therefore, have been testable, and, thus, by the testability criterion, must be scientific. Consequently, by Overton's own rationale, creationism could legitimately be taught in public school science classrooms, contra his ruling. 6. One measuring stick for everyone, the methodological equivalence of materialistic and non-materialistic, i.e., design-based, theories. Moreover, the failure of demarcation criteria to distinguish scientific from non-scientific theories applies in spades when considering materialistic versus non-materialistic, design-based, origins theories. Hence these criteria cannot justify methodological naturalism, since that principle is used precisely to eliminate non-materialistic theories, i.e., those that invoke creative intelligence as a cause. While researching the demarcation problem, one of us, Stephen Meyer, discovered an unexpected equivalent between materialistic and design-based theories with respect to their ability to meet a whole range of demarcation criteria. He has found that, invariably, if the critics of non-materialistic theories such as intelligent design apply definitional criteria, such as observability, testability, or law-like explanation, in a strict way, then these criteria not only disqualify the design hypotheses from consideration as science, they also disqualify their chief materialistic rivals, other historical scientific theories, that invoke only undirected evolutionary processes. Conversely, if definitional or demarcation criteria are applied in a less restrictive way, perhaps one that takes into account the distinctive historical aspects of inquiry into biological origins, then these criteria not only establish the scientific bona fides of various fully materialistic theories, i.e., rivals of intelligent design, they also confirm the scientific status of the design hypothesis, and other non-materialistic theories, as well. We saw this already in the case of creationism's ability to meet the criterion of testability. In no case that we have studied, however, has the demarcation criterion successfully differentiated the scientific status of non-materialistic theories, such as intelligent design, and competing materialistic theories of evolution. Either science gets defined so narrowly, in the way these criteria are applied, that the criteria disqualify both types of theory, or science is defined so broadly in the way the criteria are applied that the initial reasons for excluding intelligent design, or its competitors, evaporate. If one type of theory meets a specific criterion, then so does the other. If one type of theory fails to do so, then its rivals also fail, provided the criteria are applied in an even-handed and non-question-begging way. Theories invoking creative intelligence and their strictly materialistic rivals are equivalent in their ability to meet various demarcation criteria or methodological norms. Given this equivalence, and given that materialistic evolutionary theories are already widely regarded as scientific, there does not seem to be any reason to classify theories invoking creative intelligence as inherently unscientific by definition. Consequently, there seems to be no reason to think that scientists must limit themselves to affirming some form of undirected evolutionary process as the sole possible type of explanation for the origin and development of life on Earth, and also no reason that theists working in the sciences should have to affirm such theories, or affirm versions of theistic evolution that deny that God played an active discernible causal role in the process of creation. To illustrate this equivalence in the case of theories of biological origins, let's look at two widely cited demarcation criteria, one of which was used in the Arkansas trial and another that has been used by opponents of the theory of intelligent design, which was not yet on trial, in Arkansas. Lawful explanation. We saw already that many scientific theories do not explain by citing natural law. Some do not offer explanations at all, they describe, but do not explain, using laws of nature. Other sciences do offer explanations, but they do so by reference to causal events rather than general laws of nature. Consequently, it turns out that this demarcation criteria, must explain by natural law, offers little support for those who wish to use it to exclude design-based origins theories and, at the same time, use it to validate materialistic theories. Many historical scientific theories do not explain primarily by natural law. Instead, they postulate past events, or patterns of events, to explain other past events as well as presently observable evidence. Evolutionary theories, also, often emphasize the importance of past events, specific mutational events of various kinds, or the postulated existence of transitional forms, for example, in their explanations. Alexander Oparin's chemical evolutionary theory, for example, postulated a series of events, a scenario, not a general law, in order to explain how the first living cells arose. Similarly, in On the Origin of Species, Darwin proposed both a mechanism, natural selection, and a historical theory, the theory of universal common descent. Evolutionary biologists debate whether the mechanism of natural selection can be formulated as a general law. But within Darwin's argument, the theory of common descent had its own explanatory power. Yet it did not explain by reference to a law of nature. Instead, common descent explained a range of present-day biological and paleontological evidence by postulating a hypothetical pattern of events, as depicted in Darwin's famous Tree of Life. Common descent makes a claim about what happened in the past, namely, that a series of unobserved transitional organisms existed, forming a genealogical bridge between presently existing life forms, to account for a variety of presently observed evidence, such as the similarity of anatomical structures in different organisms, or the pattern of fossil progression. Darwin himself referred to common descent as the vera causa, i.e., the actual cause, of a diverse set of biological observations. But the theory of common descent represented a pattern of events, not a law, and yet it also clearly provided an explanation of a diverse class of facts, as Darwin put it. Of course, past events and historical scenarios are assumed to have taken place in a way that obeys the laws of nature. Moreover, our knowledge of cause and effect relationships, which we can sometimes formulate as laws, will often guide the inferences that scientists make about what happened in the past and will influence their assessment of the plausibility of competing historical scenarios and explanations. Even so, many historical scientific theories make no mention of laws at all. Laws at best play only a secondary role in historical scientific theories. Instead, events play the primary explanatory role. Ironically, as if to underscore this point, Michael Ruse, who offered the must explain by natural law criterion at the Arkansas trial, himself has noted that it is probably a mistake to think of modern evolutionists as seeking universal laws at work in every situation. The theory of intelligent design, and other such theories of origins, exemplify the same style of scientific explanation as other historical scientific theories. Intelligent design invokes a past event, albeit a mental event, rather than a law to explain the origin of information necessary to produce various novel forms of life as well as the complexity of the cell. As in other historical scientific theories, our knowledge of cause and effect, information habitually arises from conscious activity, supports the inference to design. A law, the law of conservation of information, also helps to justify the inference of an intelligent cause as the best explanation. Advocates of intelligent design use a law, since there is no informational free lunch, the origin of complex specified information always requires intelligent input, to justify their inference to a past causal event, namely, the act of a designing mind. But that act or causal event explains the evidence in question. Though laws play a subsidiary role in the theory of intelligent design, a past causal event, or events, explains the ultimate origin of biological information. Nevertheless, if explaining events primarily by reference to prior events, rather than laws, does not disqualify other historical scientific theories, including materialistic evolutionary theories, from consideration as science, then by the same logic it should not disqualify the theory of intelligent design either. Similarly, if laws can play no role or only a subsidiary role in other historical theories, then why is it inappropriate for a law to play only a supportive role in the theory of intelligent design? Conversely, if invoking a past event, rather than a law, makes intelligent design unscientific, then by the same token it should make materialistic evolutionary theories unscientific as well. Either way, the demarcation criterion, must explain by natural law, does not discriminate the scientific status of the two types of theories. Provided the demarcation criterion is applied with the same degree of rigidity or liberality, both materialistic and non-materialistic theories of origin are equivalent in their capacity to meet the definitional standard advanced in the Arkansas trial, and are, thus, either equally scientific or equally unscientific, depending on how rigidly that standard is applied. Observability. We have discovered a similar equivalent with respect to every other demarcation criterion that we have examined. Consider, for example, the oft-cited criterion of observability. According to critics of intelligent design, the unobservable character of a designing intelligence renders it inaccessible to empirical investigation and, therefore, makes it unscientific. For example, in 1993 biophysicist Dean Kenyon was removed from teaching his introductory biology class at San Francisco State University after he discussed his reasons for supporting intelligent design with his students. His department colleagues believed their actions against him were justified because they believed that he had been discussing an unscientific theory with his class. Some of Kenyon's colleagues argued that the theory of intelligent design did not qualify as a scientific theory because it invoked an unobservable entity, in particular, an unseen designing intelligence. In making this argument, Kenyon's colleagues assumed that scientific theories must invoke only observable entities. Since Kenyon discussed a theory that violated this convention, they insisted that neither the theory he discussed, nor he himself, belonged in the biology classroom. Others who defended the action of the biology department, such as Eugenie Scott of the National Center for Science Education, used a similar rationale. She insisted that the theory of intelligent design violated the rules of science because you can't put an omnipotent deity in a test tube, or keep it out of one. Molecular biologist Fred Grinnell has similarly argued that intelligent design cannot be a scientific concept because if something can't be measured, or counted, or photographed, it can't be science. But is that true? Does referring to unobservable entities or events render a theory unscientific? The answer depends, again, on how science is defined. If scientists, and all other relevant parties, decide to define science as an enterprise in which scientists can posit only observable entities or events in their theories, then clearly the theory of intelligent design would not qualify as a scientific theory. Advocates of intelligent design infer, rather than directly observe, the activity of the designing intelligence responsible for the digital information in DNA, for example. But this definition of science would render many other scientific theories, including many evolutionary theories of biological origins, unscientific by definition as well. Many scientific theories infer or postulate unobservable entities, causes, and events. Instead, scientists often infer the existence of unobservable entities in order to explain observable events, evidence, or phenomena. Physical forces, electromagnetic or gravitational fields, atoms, quarks, past events, subsurface geological features, biomolecular structures, all are unobservable entities inferred from observable evidence. Materialistic evolutionary theories also infer or postulate past unobservable events. Theories of chemical evolution invoke past events as part of the scenarios they use to explain how the first living cell arose. Insofar as these events occurred millions of years ago, they are clearly not observable today. Neo-Darwinian biologists, for their part, have long defended the putatively unfalsifiable nature of their claims by reminding critics that many of the creative processes to which they refer occur at rates too slow to observe in the present and too fast to have been recorded in the fossil record. Furthermore, the existence of many transitional intermediate forms of life, the forms represented by the nodes on Darwin's famous branching tree diagram, are also unobservable. Instead, as noted, unobservable transitional forms of life are postulated to explain the pattern of observable biological evidence, as Darwin himself explained. But how is this different in principle from postulating the past activity of an unobservable designing intelligence to explain observable features of the living cell or the pattern of appearance in the fossil record? Neither Darwinian transitional forms, neo-Darwinian mutational events, the rapid branching events of Stephen Jay Gould's theory of punctuated equilibria, the events comprising chemical evolutionary scenarios, nor the past action of a designing intelligence are directly observable. With respect to direct observability, each of these theories is equivalent. Thus, if the standard of observability is applied in a strict way, neither intelligent design nor any other theory of biological origins qualifies as a scientific theory. But if the standard of observability is applied in a more flexible and, perhaps, realistic way, then both materialistic and non-materialistic theories, those that invoke unobservable actions of a creative intelligence, should be considered equally scientific. Indeed, both types of theories are equivalent in their ability to meet the demarcation criterion of observability and every other criterion that we have examined. It has been said that behind every double standard lies a single hidden agenda. It takes only a smattering of philosophical training, and even less historical sophistication, to see that the flawed demarcation criteria cited in MacLean had been specially contrived by the ACLU to try to discredit creationism. But if we take the criteria seriously, and apply them dispassionately with an unabridged history of science in hand, the methodological equivalence of theories of materialistic evolution and intelligent design, or other non-materialistic theories invoking creative intelligence, emerges quite naturally, almost as if philosophy of science herself had refused to take the role of referee in our scientific disputes. Proponents of competing scientific theories must fight it out, however messy that may be, i.e., their theories must compete for the standing of best explanation, with the evidence as the final arbiter. There is no philosophical shortcut to empirical truth, indeed, if abstract methodological criteria could perform that task, why bother with examining the evidence? 7. The permitted versus the possible, science as open-ended quest. Thus far, none of the arguments advanced in support of a naturalistic definition of science has provided a justification for methodological naturalism. Nevertheless, perhaps such arguments are irrelevant. Perhaps scientists should just accept the definition of science that has come down to them. After all, the search for natural causes or materialistic processes has served science well. What compelling reasons can be offered for overturning the prohibition against design-based explanations in science? What harm can come from continuing with the status quo? In fact, methodological naturalism damages science, and for several interrelated reasons. First, with respect to origins, defining science as a strictly materialistic enterprise limits the ability of scientists to determine the truth, to find out what actually happened to cause life to arise on Earth. Consider, it is at least logically possible that a personal agent or a creative intelligence existed before the appearance of the first life on Earth, and that such an agent played a causal role in the origin and development of life. Further, proponents of intelligent design have shown in other places that we do live in the sort of world where knowledge of such an agent could possibly be known or inferred from empirical data. This suggests that it is logically and empirically possible that such an agent designed or influenced the origins of living forms on Earth in an empirically detectable, to us, way. To insist that postulations of creative intelligence are inherently unscientific in the historical sciences, where the express purpose of such inquiry is to determine what happened in the past, simply excludes by assumption a logically and empirically possible answer to the question motivating historical biology: what actually happened to cause life to arise on Earth? Indeed, the historical question that must be asked about biological origins is not which materialistic scenario will prove most adequate, but how did life as we know it actually arise on Earth? Since one of the logically possible answers to this later question is life was designed by an intelligent agent that existed before the advent of humans, it seems contrary to the truth-seeking function of the natural sciences to exclude the design hypothesis without a consideration of all the evidence, including the most current evidence, that might support it. This conclusion has been reinforced by recent developments in the philosophy of science. Recent accounts of scientific rationality in the philosophy of science suggest that scientific theory evaluation is an inherently comparative enterprise. Notions such as consilience and Peter Lipton's inference to the best explanation imply the need to compare the explanatory power of competing hypotheses or theories. If this process is subverted by philosophical gerrymandering, the rationality of scientific practice is vitiated. Theories that gain acceptance in artificially constrained competitions can claim to be neither most probably true nor most empirically adequate. Instead, such theories can only be considered most probable or adequate among an artificially limited set of options. We illustrate the way in which methodological naturalism impedes the truth-seeking function of science visually with Figure 19.1, a Venn diagram depicting the logical relationship between what is empirically possible versus what our scientific methods, under the rule of methodological naturalism, have permitted us to infer. Notice that the space of what is possible, that is, the space of what might be true, should the evidence turn up, extends far beyond, and encloses, the space of what has been permitted under methodological naturalism. This asymmetry, between what is possible and what has been permitted, will not necessarily trouble the philosophical materialist or naturalist who simply assumes that there cannot have been creative intelligence at work in the production of life or the universe. Thus, for them the boundary line of what might be true empirically is coextensive precisely with what the methods of science, as defined by methodological naturalism, allow as possibilities. But the asymmetry between the possible and the permitted should bother everyone else, starting with intellectually curious naturalists, atheists, and agnostics who want to know whether the evidence from the natural world actually supports their scientific philosophy, worldview, and preferred origins theories. Those who cherish their intellectual independence do not like to be told what they can or cannot know about the universe. Methodological naturalism doesn't open up explanatory options and possibilities, it can only take them away. The asymmetry between the possible and the permitted, as imposed on science by methodological naturalism, should bother theists and Christians most of all, including theistic evolutionists who have accepted methodological naturalism as defining science. Figure 19.1 gives the reason. For theistic evolutionists, the whole of reality is not, and never could be, coextensive with the physical or material universe, if the adjective theistic has any content, that is. Thus, not only is it possible that a personal agent existed before the first appearance of life on Earth, and before the universe itself came to be, rather, this is what theistic evolutionists take to be the case. After all Christian theists, including theistic evolutionists, affirm that in the beginning was the Word. 8. An explanatory palette for science. Science, without limit. Ironically, many atheistic scientists and philosophers of science now themselves reject methodological naturalism precisely because they see that it impedes an open-ended search for the truth about the universe, life, and reality. As the Caltech physicist, and atheist, Sean Carroll, whom we quoted earlier, has explained, science should be interested in determining the truth, whatever that truth may be, natural, supernatural, or otherwise. The stance known as methodological naturalism, while deployed with the best of intentions by supporters of science, amounts to assuming part of the answer ahead of time. If finding truth is our goal, that is just about the biggest mistake we can make. Other atheists or committed scientific materialists now agree. Mathematician Jason Rosenhaus of James Madison University also objects to methodological naturalism as a non-negotiable first principle. Viewed as a fundamental ground rule to which science must always and everywhere adhere, he writes, methodological naturalism seems dogmatic and unnecessary. University of Texas philosopher and biologist Sahotra Sarkar, himself a philosophical naturalist, worries that trying to rule out intelligent design in terms of demarcation criteria or on the basis of methodological naturalism is both unnecessary and, it seems to me, a tactical mistake. Lastly, Belgian philosopher of science and atheist Martin Boudry, evaluating the status of methodological naturalism, argues that the most widespread view, which conceives of methodological naturalism as an intrinsic or self-imposed limitation of science, is philosophically indefensible. But why would atheists and philosophical naturalists worry about methodological naturalism? It is clear from their writings that Carroll et al. Want materialistic theories of evolution to have prevailed in a fair competition, winning their place in science because those theories explain the data better than any design-based competitors. They see an openness to empirical arguments for intelligent design, and against the adequacy of undirected materialistic evolution, as a necessary condition of a fully rational historical biology, one that is committed to following the evidence wherever it leads, and one where the evidence might have shown their favored theories to be wrong. As Sarkar stresses, naturalism as a philosophy, as well as naturalistic theories of evolution, should be defeasible, i.e., possibly wrong. Most importantly, he writes, since naturalism is derived from experience, it, as well as any other philosophical position, is fallible, just like the claims of science. Methodological naturalism, however, when delivered as an a priori diktat armored by must and only, renders the proposition, life arose via undirected materialistic or naturalistic evolutionary processes, anything but defeasible. As Rosenhaus worries, to say that science requires this ground rule, or that one denies God a role in the creation while doing science, certainly makes it sound as though, no matter how strongly the evidence pointed to design, scientists, in their professional work, would simply be forced to disregard it. And that, again, damages the truth-seeking goal of science, which is, in fact, the most compelling reason to reject methodological naturalism. 9. Objection: do non-naturalistic theories commit the God of the gaps fallacy? Defenders of methodological naturalism frequently justify its prohibition against non-materialistic explanations by claiming that any such explanation for the origin of new forms of life, such as intelligent design or special creation, would necessarily commit a God of the gaps fallacy. According to those who raise this objection, a God of the gaps fallacy occurs when proponents of design or creation invoke the activity of a designing intelligence or creator to explain some unexplained phenomenon or feature of the natural world. Doing this, they argue, necessarily invokes the action of a designing intelligence to fill a gap in our knowledge of the true causes of a given phenomenon or feature and, consequently, hinders or stalls scientific inquiry. By searching for naturalistic or materialistic causes only, the objection continues, we avoid inserting God, or mind or intelligence, into the gap in our understanding, a gap that will inevitably be filled by genuine knowledge of a physical, material, or natural mechanism or process. But to what does the word gaps in this objection refer? Imagine someone who mistakenly enters an art gallery, expecting to find croissants on sale, that is, someone who thinks the gallery is a fancy bakery where pastries and rolls are sold. Such a person may think that he has encountered a puzzle about the wares provided by the business. He may even think that he has a gap in his knowledge of what must definitely be present somewhere in the museum. I cannot see the baked goods, so they must keep them in the back room. Clever minimalism. Based on his assumptions, the visitor may then stubbornly cling to his perception of a gap, insisting it is real and badgering the gallery staff to bring out the croissants already, until with exasperation they show him to the exit. The moral of our little story? The gallery visitor sees an unsolved puzzle, or perceives a gap in his knowledge about the location of the baked goods. Both the puzzle and the gap, however, derive from his false assumption that he has walked into a bakery. In a similar way, perceived gaps in our knowledge of natural processes responsible for given phenomena or features of the world are based on our background assumption about the kind of processes or entities that ought to be present in nature. In the debate about biological origins, theistic evolutionists and mainstream evolutionary biologists assume that all living systems necessarily were produced by some naturalistic process, and that their origin will, thus, ultimately have a completely naturalistic or materialistic explanation. The background assumption implicit in, for instance, the question how did life first arise via materialistic chemical evolutionary processes or pathways? Implies a gap in our scientific knowledge when it becomes apparent, as it has, see Chapter 3, that no satisfactory materialistic chemical evolutionary process has been discovered that can generate living cells from simpler non-living molecules. But our present lack of knowledge of any such chemical process entails a gap in knowledge of the actual process by which life arose only if such a materialistic chemical evolutionary process actually did produce the first life. Yet if life did not arise via a strictly materialistic chemical evolutionary process, but was, for example, intelligently designed or specially created, then our absence of knowledge of a strictly materialistic process responsible for life does not represent a gap in knowledge of an actual process, i.e., one that actually exists and or was acting in the past. In that case, the perceived gap in our knowledge would merely reflect a false assumption about what must have happened, or a false assumption about the existence of a certain kind of process. Namely, a materialist one with the creative power to generate life. But what if such a materialistic process did not produce either the first life or fundamentally new forms of life? Theistic evolutionists use the God of the Gaps objection to justify the claim that scientists should consider only materialistic evolutionary theories to explain the origin of new living forms, i.e., they use it to justify methodological naturalism. Yet, their use of the God of the Gaps objection to justify methodological naturalism ultimately begs the question. Why? Because the claim that gaps in our knowledge of materialistic evolutionary processes constitutes an actual gap in knowledge of how life forms came to be assumes that materialistic evolutionary mechanisms must have produced new forms of life, and, thus, must explain the origin of those forms. But that is simply the assumption of materialism, metaphysical and methodological, in another form. Yet, methodological materialism or naturalism is precisely what theistic evolutionists invoke fear of the God of the Gaps fallacy to justify. We can unpack the circularity of this reasoning still further. Theistic evolutionists justify protecting materialistic evolutionary theories, despite their empirical shortcomings, from theoretical competition from non-materialistic origins theories by invoking methodological naturalism. They justify methodological naturalism by invoking fear of the God of the Gaps fallacy. But the gaps to which they refer in warning against this alleged fallacy are only gaps if evidence shows that there are materialistic evolutionary mechanisms capable of generating biological novelty, that is, if there is an adequate, fully materialistic evolutionary theory. But since many theistic evolutionists admit that there isn't such a theory, they justify their exclusionary commitment to some form of fully materialistic evolutionary theory by invoking none other than methodological naturalism, which they justify by invoking the God of the Gaps fallacy. And around they go. Thus, using fear of the God of the Gaps fallacy to justify methodological naturalism subtly assumes a materialistic answer to the central question at issue, namely, how did life actually arise? Yet, again, rather than assuming that life must have arisen by strictly materialistic processes, scientists interested in finding out what caused life to arise would do better to ask a more open-ended question of nature, such as, what actually happened to cause new forms of life on Earth to come into existence? Seen in this light, the God of the Gaps objection fades into insignificance. To have force, theistic evolutionists must first show that we have genuine gaps in our knowledge of materialistic causes of the origin of new forms of life, i.e., that we have grounds for thinking that present gaps will ultimately be filled with knowledge of an actual natural process or mechanism capable of biological innovation. But this, as we showed in chapters 1 to 9, is exactly what evolutionary biologists and theistic evolutionists have failed to do. Indeed, if theistic evolutionists had discovered materialistic processes with demonstrated creative power, or if they had empirical grounds for thinking that such processes do exist, they would not need to invoke methodological naturalism or justify methodological naturalism by warning of the God of the Gaps fallacy. Nor would they need to declare their commitment to waiting indefinitely for an adequate materialistic evolutionary explanation for the origin of biological novelty to emerge. Instead, the fact that they cannot justify their confidence that some materialist evolutionary process will ultimately prove sufficient to explain the origin of novelty means that they don't know that there is a gap in our knowledge of such a process, that is, of an actual process at work in nature, either now or in the past. Indeed, they have no grounds for believing in the existence and causal powers of such a hypothetical process apart from their prior commitment to methodological naturalism, which is the very principle they seek to justify by invoking the spectre of the God of the Gaps objection. Conclusion. We have seen that there are no neutral methodological criteria by which we can define science normatively and exhaustively. But fruitful science does not need definitions, it needs creativity, hard work, and evidence most of all. We have also seen that specific demarcation criteria fail to distinguish the scientific status of materialistic and design-based theories of biological origins, i.e., the proposed justifications in support of methodological naturalism fail. In addition, we have seen that there is a strong affirmative reason to reject methodological naturalism, namely, that it hinders the truth-seeking function of science by forcing scientists to reject the possibility that a creative intelligence played a discernible role in the origin and history of life, even before experience can freely testify. Methodological naturalism gives nothing to scientists but intellectual bondage and limited options. Even if the authors of this chapter were atheists, we would not want to work with the chains of methodological naturalism around our ankles. Nor should theistic evolutionists. They will lose nothing by letting go of this wretchedly bad rule, erasing a philosophical boundary that never should have been drawn in the first place. But whether they do so or not, it should now be clear that there is no compelling reason to accept methodological naturalism and every good reason to reject it. Consequently, there is no reason to continue holding to theistic evolution in the face of the mounting evidential difficulties that now confront all theories of unguided evolution. It may well be time to consider alternative types of causal explanations for the origin and development of life, to consider, for example, the possibility, at least, of intelligent design and its explanatory power. And, why not? Basketball is better with the three-point shot. More fun to play, more fun to watch. 20. How to lose a battleship, why methodological naturalism sinks theistic evolution. Stephen Dilley. Summary. Theistic evolutionists should reject methodological naturalism. Among other reasons, methodological naturalism prohibits both, 1, the use of theology-laden claims within scientific discourse and, 2, scientific engagement with so-called non-scientific theories, like creationism and intelligent design. And yet, key scientific arguments for evolutionary theory, from the origin to the present, either rely on theology-laden claims or engage creationist, or intelligent design, theories in a scientific manner. Under methodological naturalism, however, this dynamic is not acceptable. Accordingly, if theistic evolutionists accept methodological naturalism, they forfeit significant justification for their favored theory. Insofar as theistic evolutionists wish to retain this justification, they ought to set methodological naturalism aside. The year 1866 was conspicuous for Charles Darwin. Scientific consensus was at last leaning toward common ancestry and away from special creation. Darwin keenly monitored this development. In the fourth edition of The Origin, published that year, he inserted a new claim, namely, that special creation's account of homology was not a scientific explanation. In the first 3 editions, Darwin's general strategy had been to attack special creation as empirically false and explanatorily empty. But in the fourth edition, he flatly characterized special creation as beyond the pale of science. He went on to reiterate this claim in the fifth edition and, by the sixth and final edition, added 3 more claims to similar effect. Yet through all 6 editions, Darwin also continued to give scientific arguments as to why evolutionary theory was empirically superior to special creation. Moreover, Darwin also deployed an array of partisan theological claims as part of his positive argument for evolutionary theory. In effect, he adopted a dual strategy: assail special creation using scientific arguments and, when useful, declare that special creationism is not scientific. This tactic enabled Darwin to maximize his empirical argument as well as capitalize on the scientific community's shifting allegiance toward common ancestry. The move gave the origin considerable rhetorical power. But it also came at an epistemic cost. Darwin's dual strategy was intellectually incoherent. 2 mutually exclusive options were on the table, and Darwin took both. A similar dilemma persists to the present day. As we will see, contemporary theistic evolutionists cannot coherently accept scientific arguments that support evolutionary theory over creationism and also accept methodological naturalism, which bars creationism from scientific analysis. My core thesis in this chapter is that theistic evolutionists should reject methodological naturalism. Doing so allows them to retain a central justification for evolutionary theory, the apparently overwhelming evidence that supports it over all rivals. My argument falls into 4 parts. In part 1, I set the stage by defining relevant terms, noting clarifications, and the like. In part 2, I move to the body of my argument, contending that theistic evolutionists must choose one of the 2 mutually exclusive routes outlined above. In part 3, I argue against methodological naturalism by exploring several ways in which evolutionary thinking involves theology. As we will see, for example, many evolutionary biologists routinely treat creationism as a scientifically testable theory, marshalling empirical evidence to refute it. More strikingly, a wide range of scientific arguments for evolutionary theory actually depend on theological claims. Collectively, these ways of supporting evolutionary theory involve God talk, and thus run contrary to methodological naturalism. In part 4, I turn to the other strategy available to theistic evolutionists: accept methodological naturalism and treat creationism as outside of science. I argue that this approach fails. The reasons for methodological naturalism are weak, while reasons against it are strong. Among other things, I contend that acceptance of methodological naturalism greatly harms the case for evolutionary theory, rendering scientific evidence impotent to support evolutionary theory over creationism. All told, if theistic evolutionists wish to retain maximum support for evolution, if they wish to keep their battleship, they ought to discard methodological naturalism. Part 1, setting the stage. Definitions. Before turning to the main argument, a few definitions are necessary. First, what is methodological naturalism? There are a number of conceptions afoot, yet the mainstream version holds that, like all domains of human inquiry, science has a particular scope, context, and purpose, namely, to focus solely on the properties and processes of nature. As such, the only permissible explanations within scientific research, articulation, and argument are those that appeal to natural entities, causes, processes, laws, and the like. While theological explanations for natural phenomena may be legitimate in their own right, they fall outside the purview of science proper. In short, natural explanations, rather than theological ones, belong in science. A brief exposition of this conception of methodological naturalism is in order. First, methodological naturalists offer an array of reasons for the convention that draw upon theological, historical, empirical, conceptual, and pragmatic grounds. I will turn to these in due course. For now, it's important to note that, according to methodological naturalists, the convention is not an arbitrary rule imposed upon science but a thoughtful conclusion based on reflection about the nature, context, and purposes of science. Second, methodological naturalism does not imply that natural causes, laws, etc., are in contrast to God's governance of the cosmos. In fact, Christian methodological naturalists typically regard natural causes and laws as secondary causes and laws, that is, as God's ordinary way of ruling the universe. God ontologically sustains creation, upholding all things by the word of his power, Hebrews 1 verse 3. From this vantage, methodological naturalism allows a rich dialogue between science and theology. Even if science and theology are distinct disciplines with their own contexts and purposes, the prohibition of God talk within science in no way suggests that theology and science have nothing vital to say to each other in conversation. For example, theology can play a meta-level role in motivating, inspiring, and sanctioning scientific work and discourse. In particular, many methodological naturalists believe theological perspectives offer accounts that are complementary to scientific explanations. A scientist can gaze at a sunset and describe how the atmosphere scatters blue and violet light away from his vision, making the sky appear more red and pink. A theologian can behold these colors and say, with equal truthfulness, "The heavens declare the glory of God. The skies proclaim the work of his hands." Psalms 19 verse 1 NIV. Under methodological naturalism, both accounts can be correct. And, just as important, both can be essential for a comprehensive and textured understanding of the natural world. In addition, with methodological naturalism, science and theology can be, or ought to be, integrated in one's life and thought. While science and theology are different disciplines, nonetheless individuals arguably ought to partake of both areas, melding each complementary account into their personal unified experience. The scientist who describes the properties of light in a sunset can be the same person who also discerns God's reflected glory. In fact, a Christian who is a scientist can affirm that scientific inquiry reveals possible means through which God has created the world and continues to work in nature. On this view, a believer who studies nature as a scientist is engaged in profound worship of the Almighty. For Christian methodological naturalists, science and theology embrace in deep accord. Having noted that methodological naturalism allows a complementary relationship between science and theology, especially in the life of believing scientists, I now wish to focus on what methodological naturalism implies within science itself, the central focus of this chapter. As mentioned, methodological naturalism runs contrary to the incursion of theological explanations within scientific research and discourse. At a deeper level, methodological naturalism also prohibits any substantive theological propositions within science. All things being equal, it would be arbitrary to bar theological explanations but allow other theological propositions, especially if these propositions were neither shared by all scientists nor necessary for particular, or general, types of scientific reasoning or research. If methodological naturalism means anything at all, it means that God talk is barred within science in toto. As theistic evolutionists Dennis Alexander, Holmes Rolston III, and Geoffrey Schloss note, the very purpose of science is to explain the workings of nature without recourse to religious language. Or as Michael Ruse observes, the methodological naturalist insists that, inasmuch as one is doing science, one avoid all theological or other religious references. And the National Academy of Science says simply, the statements of science must invoke only natural things and processes. Consequently, a straightforward implication of methodological naturalism is that scientific investigation, articulation, argument, and explanation ought to remain free of theological claims. In sum, from the point of view of Christian methodological naturalists, science is simply one tool for understanding the physical world. A complete understanding of creation requires a broader Trinitarian framework. On this view, the scientific enterprise ultimately rests on religious moorings, and the deliverances of science are held to be insights into God's work in and through creation. Yet science itself is regarded as a limited endeavor. It has a circumscribed domain that focuses exclusively on natural, or secondary, phenomena. Claims about God's actions, nature, or purposes are not permitted, even if these are necessary for a full, theological, understanding of creation. From this perspective, when scientists engage in scientific work as scientific work, they are to avoid religious language. Having clarified the heart of methodological naturalism, I note that the convention comes in two flavors, intrinsic and pragmatic. The former treats methodological naturalism as an inviolable rule that governs science. Theological claims are never allowed within scientific discourse or research, even in principle. The latter is more modest. On this view, the default practice of scientists within the context of their field should be to explain natural phenomena by reference only to natural, or secondary, causes, laws, and the like. But scientists can be open to supernatural explanations, or claims, within science proper, should the need arise. In this chapter, I use the term methodological naturalism to refer to the intrinsic version. I will address the pragmatic version separately in Part 4. What is theistic evolution? In general, the view holds that God planned or guided the evolutionary process. There are variations and exceptions to this main theme, yet most versions have in common the claim that God's design of biological phenomena, or history, is not empirically detectable using the rigorous methods of science. God signs his handiwork using invisible ink, as they say. A few other definitions will round out matters. By evolutionary theory, or just plain evolution, I mean standard neo-Darwinism, although my argument applies equally well to any other, naturalistic, theory that explains the origin of biological complexity without reference to God's empirically detectable design. I use the term theological theory in a stipulated way. I mean a claim, or set of claims, about a supernatural agent's action, vis-à-vis biological phenomena, or history, in a manner that purports to be scientifically confirmable or falsifiable, in principle. Because this is precisely the type of theory that methodological naturalism rejects within science, it is directly relevant to assessing the viability of methodological naturalism. For stylistic variety, I will sometimes use instead the terms supernatural theories, or God hypotheses. By creationism, I mean a theological theory in which the deity in question is the God of the Bible, who is said to have created in a manner that accords with a more or less literal reading of Genesis 1. Finally, just to be clear, by theology, I mean propositions about any supernatural being. Clarifications. Several key items remain to be clarified. First, the crucial difference between theological theories and theistic evolution, as I've characterized them, turns on whether there is scientific evidence of God's design in biological phenomena or history. The former affirms this, while the latter denies it. The difference between the two is not about the following: whether God ontologically sustains creation, including its causal properties and events. Many theological theories are compatible with a robust view of God's ongoing ontological involvement in all of creation. Whether God created a given biological phenomenon by a direct miracle or, alternatively, indirectly through secondary, or natural, means. Some theological theories are perfectly compatible with either option. Whether common ancestry is true. As with the previous point, some theological theories are perfectly compatible with this thesis. At what time in history God designed organisms or their features? For present purposes, it matters little whether God acted during biological history or instead, front-end loaded the cosmos at its initial creation so that it expressed marks of design later in biological history. Whether God designed anything at all in organic history or, if he did, how many things. None of these points mark the salient difference between theistic evolution and theological theories. Instead, what separates them is epistemological, whether there is empirically detectable scientific evidence of God's design in biological phenomena or history. Crucially, the line that separates theistic evolution from theological theories does not hinge on the acceptance, or rejection, of methodological naturalism. Both approaches are compatible with either this convention or its denial. In particular, theistic evolutionists are free to discard methodological naturalism. That is, they can allow religious language, including theological theories, into science proper while also accepting that evolutionary theory provides a true physical explanation of organic history. In this approach, theological theories are regarded as false but not necessarily as unscientific. A false theory may still be a scientific one. In fact, the history of science is littered with such theories. The rejection of methodological naturalism simply means that God talk is permissible within scientific research and discourse. It does not imply any judgment regarding the truth or falsity of this God talk. Methodological naturalism itself concerns what counts as scientific, not what counts as correct per se. As such, theistic evolution is fully compatible with the rejection of this convention. A third clarification focuses on intelligent design theory, ID. Is it a theological theory? Opinions vary. For now I grant that ID is a theological theory. Given that many theistic evolutionists regard it as such, but my argument does not hinge upon the matter one way or the other. I should note in passing that if ID is not a theological theory, then methodological naturalism, which prohibits theology, poses no barrier to regarding ID as fully scientific. Fourth, I want to be clear that this chapter does not dispute the truth of evolutionary theory or of theistic evolution. The truth or falsity of these positions is the subject of other chapters in this volume. Instead, my concern is simply whether theistic evolutionists ought to embrace methodological naturalism. Finally, although I suspect that most theistic evolutionists hold or apply methodological naturalism in an inconsistent way, my purpose here is not to argue for this claim. Instead, my central thesis is that, regardless of any alleged inconsistency, theistic evolutionists ought to reject methodological naturalism. Theistic evolution and methodological naturalism, compatible companions? As it happens, the overwhelming majority of theistic evolutionists accept methodological naturalism in one form or another. Although some thinkers are not totally clear, the list of those who accept it apparently includes Dennis Alexander, Ian Barber, Ernan McMullin, Keith B. Miller, Francis Collins, Ord Louis, Darrell Falk, Mark Sprinkle, Mark Mann, Robert Bishop, Robert O'Connor, Edward Davis, Richard Wright, Catherine Applegate, Dennis Lamoureux, Connor Cunningham, Jeff Hardin, Carl Giberson, Jeffrey Schloss, Holmes Rolston III, Kenneth Miller, and others. At an organizational level, one of the leading groups of theistic evolutionists in the United States, BioLogos, also accepts methodological naturalism. At BioLogos, we believe that our intelligent God designed the universe, but we do not see scientific or biblical reasons to give up on pursuing natural explanations for how God governs natural phenomena. BioLogos' allegiance to methodological naturalism is part of its overall mission to persuade Christians, especially evangelicals, to accept evolutionary theory as ironic to robust faith. Many other national or international organizations likewise adhere to methodological naturalism. Indeed, a strong majority of scientists, whether theistic or otherwise, regard methodological naturalism as canonical for biological research and discourse. Part 2, Mutually Exclusive Roots. Having set out the initial groundwork, I now turn to the body of the chapter. Theistic evolutionists have two primary routes by which to support evolutionary theory and counter rival theological theories. These routes are mutually exclusive, choosing one means foregoing the other. The first route is to adopt methodological naturalism. On this path, theistic evolutionists can claim that there are good grounds to exclude God hypotheses from biology. These grounds are generally theological, historical, conceptual, empirical, or pragmatic. Yet because methodological naturalism bars supernatural theories from science proper, it follows that methodological naturalism also prohibits scientific analysis of such theories. Consequently, theistic evolutionists can neither use scientific arguments to critique these theories nor to favor evolutionary theory over them. Of course, biologists who take this route can draw on scientific evidence to support evolutionary theory over other naturalistic, or secondary, theories, but they cannot do so to support evolutionary theory over God hypotheses. I will examine this methodological naturalism only route for theistic evolutionists in Part 4. By contrast, an alternative route rejects methodological naturalism. In this approach, theistic evolutionists can bolster evolutionary theory and critique supernatural rivals by placing them in head-to-head competition within science. On this basis, theistic evolutionists can argue that evolutionary theory is empirically superior to its theological counterparts. I will examine this route in Part 3. As noted, the two routes described here are mutually exclusive. If theistic evolutionists adopt methodological naturalism, which prohibits theology within biology, then they cannot make a scientific argument against God hypotheses, nor can they utilize theology in their positive scientific case for evolution. If you pays your money, as the old saw goes, you takes your choice. The landscape looks as shown in Table 20.1. Table 20.1. Two mutually exclusive routes to support evolutionary theory and counter theological theories. A critic might disagree with this way of carving up the territory. He might contend that, even while holding methodological naturalism, theistic evolutionists can still make extensive empirical evaluation of God hypotheses, yet do so under the rubric of a non-scientific discipline such as natural theology, or something similar. Alternatively, a critic might contend that theology-based views can be scientifically evaluated without any God talk, and so without violating methodological naturalism. Suppose, for example, a paleontologist wished to evaluate the scientific credentials of young Earth creationism. Suppose further that young Earth creationism predicts that humans and dinosaurs lived during overlapping geological eras. Can't a paleontologist scientifically assess this claim without using any theological statements? After all, he would mainly analyze fossils and wouldn't rely on propositions about God per se accordingly. Since theology is not present, no violation of methodological naturalism occurs. In response to this last objection, the matter is surely complex. In a sense, much of my chapter functions as a reply to this objection. For now, I note that theology is actually quite relevant to the young Earth case, as it is to other cases discussed in this chapter. The proximate claim under assessment is that humans and dinosaurs lived during overlapping geological eras. While assessing this claim in isolation requires no theological language, the claim in context is part of a broader conditional. If young Earth creationism is true, then humans and dinosaurs lived during overlapping geological eras. The very reason to analyze the consequent in the first place arises from the crucial presence of the antecedent. And the antecedent is simply shorthand for a set of specific claims about the God of the Bible. Moreover, if the consequent turns out to be false, then, in light of the conditional about young Earth creationism, modus tollens mandates that young Earth creationism is likewise false. Thus, in this context, empirical observations and logical implications inevitably touch theology. God talk is clearly present, in direct violation of methodological naturalism. I turn now to the first criticism, which held that God hypotheses can undergo extensive empirical evaluation under a non-scientific heading, such as natural theology. This possibility amounts to little more than superficial relabeling. As a de facto matter, this evaluation is scientific. While other disciplines make use of empirical data, the hallmark of science is extensive empirical analysis. Thus, all things being equal, any such examination of a supernatural theory ought to be regarded as a scientific one. Accordingly, unless one wants to play word games, theistic evolutionists must choose one of two mutually exclusive routes: adopt methodological naturalism and so be silent about the empirical credentials of God hypotheses, or attack these hypotheses and establish evolutionary theory in head-to-head empirical competition. Part 3: God Talk in Evolutionary Reasoning. Theology alive and well. Evolutionists have a long history of both engaging God hypotheses on scientific grounds and using theology in the scientific case for evolutionary theory. Darwin's theory, after all, originally arose in response to a theological counterpart. As historian Abigail Lustig observes, modern evolutionary biology traces its descent, with modifications, from Charles Darwin, and most particularly from The Origin of Species of 1859. The Origin was itself created as a response to one of the greatest conundrums of natural history, the order and diversity of life, and to one of its most convincing answers, the theological argument from design. Evolutionary theory was, in short, born in theology. As other scholars have observed, in The Origin, Darwin borrowed from natural theology similar research problems, presuppositions, patterns of argumentation, metaphors, concepts, and content. More poignantly, Darwin plainly stated in the introduction to The Origin that one of his chief goals was to argue that special creation is erroneous. Throughout The Origin, his one long argument for evolution repeatedly engaged in an empirical combat with this theological rival. But Darwin didn't simply critique a theological counterpart in The Origin, he actually deployed theology-laden claims as part of his extended argument. These theological claims were not mere rhetorical flourish designed to persuade a Victorian audience, they were crucial elements of several of his epistemic arguments for evolution. These theology-laden claims include: human beings are not justified in believing that God creates in ways analogous to the intellectual powers of the human mind. A God who is free to create as he wishes would create new biological limbs de novo rather than from a common pattern. A respectable deity would create biological structures in accord with a human conception of the simplest mode to accomplish the functions of these structures. God would create only the minimum structure required for a given part's function. God does not provide false empirical information about the origins of organisms. God impressed the laws of nature on matter. God directly created the first primordial life. God did not perform miracles within organic history subsequent to the creation of the first life. A distant God is not morally culpable for natural pain and suffering. the God of special creation, who allegedly performed miracles in organic history, is not plausible given the presence of natural pain and suffering. None of this ought to be surprising. Cornelius Hunter has noted that evolutionary theory's pedigree includes centuries of engagement with design theories. C. Untrusted thinking is pervasive in evolutionary thought. The alternative model, against which evolution is compared, is independent creation. Since the 17th century, scientists, philosophers, and theologians have elucidated a wide spectrum of refutations of design and creation. With Darwin, these refutations were applied to the origin of species. In fact, the contest between natural and supernatural explanations of the physical world has been intertwined with the Western tradition from its inception. Classicist David Sedley points out that the matter was considered fundamental by ancient thinkers like Socrates, Plato, Aristotle, Anaxagoras, Empedocles, Democritus, the Epicureans, and the Stoics. Little wonder that this pattern extends into the 21st century. Many contemporary biologists, both theistic evolutionists and others, rely on claims about God's nature and ways in their scientific case for evolution. These luminaries include Francis Collins, Kenneth Miller, Dennis Alexander, Theodosius Dobzhansky, Ian Barber, Carl Giberson, Francisco Ayala, Niles Eldridge, Douglas Futuama, John Avise, Neil Shubin, Jerry Coyne, Richard Dawkins, George Williams, Stephen Jay Gould, and many others. Theology-laden arguments appear in major areas of biology, including genetics, embryology, biogeography, paleontology, physiology, organic diversity, genomics, and the like. Biologists who make these arguments overwhelmingly view them as scientific, no doubt because they draw on scientific data, inferences, patterns of reasoning, and peer-reviewed research. Moreover, careful analysis shows that these theological claims are typically indispensable to the arguments in which they appear. Without God talk, the arguments do not support evolutionary theory. More poignantly, these arguments are often central to a given thinker's overall scientific case for evolution. Indeed, some of these thinkers' self-reported best arguments for evolution depend upon God talk. Things below, it seems, rest upon things above. Just to be clear, my claim is not that evolutionary theory itself contains theological propositions. Instead, my claim is that self-reported scientific justifications for this theory often include theological claims. Moreover, my claim is not that every biologist who utilizes theology in his case for evolution is a religious believer. In fact, some atheists and agnostics have the strongest opinions about what God would have done in organic history, were he to exist. And while some of these theological claims are entailed by creationism, a number of them are foreign to creationism and ID. That is, evolutionists often import their own partisan theology into their scientific case for evolution and against creationism or ID. They bring their own God talk to the table. Notably, the widespread use of theology occurs not just in debates with creationists or intelligent design theorists but even in neutral, or purely scientific contexts such as encyclopedia entries or textbooks. That is, even when the rhetorical setting is a straightforward description of the reasons for evolution, theological claims often surface, including in sections explicitly marked, the evidence for evolution. This entrenched pattern clearly runs contrary to methodological naturalism. If religious language ought to be cordoned from biological science, then much of the case for evolutionary theory, past and present, remains curiously off-limits to biology proper. To paraphrase a familiar saying, theistic evolutionists cannot serve both God and methodological naturalism. They must choose between a full-blooded scientific case for evolution on the one hand or their naturalistic method on the other. Two examples of theological involvement in evolutionary reasoning. Having noted the pattern of theological involvement in the case for evolutionary theory, I now turn to two extended examples. They capture two complementary ways that evolutionists typically use to support their favored theory. First, evolutionists sometimes deploy explicit theological claims as part of their scientific case for evolution or as part of their scientific case against supernatural theories. At other times, evolutionists use only non-theological claims but employ them in arguments directly against God hypotheses. Both approaches violate methodological naturalism. Example 1, God and the Eye. Francis Collins is perhaps the most prominent theistic evolutionist in North America. His resume includes pioneering the groundbreaking Human Genome Project, garnering both the National Medal of Science and the Presidential Medal of Freedom, and receiving an appointment as director of the National Institutes of Health, including management of its modest $26 billion budget. In his best-selling The Language of God, Collins contends that the imperfection of the vertebrate eye confirms evolutionary accounts but poses a grave problem for intelligent design. He notes that, while Darwin recognized the challenge the eye presented to his theory, nonetheless Darwin proposed 150 years ago a series of steps in the evolution of this complex organ, which modern molecular biology is rapidly confirming. By contrast, the design of the eye does not appear on close inspection to be completely ideal. The rods and cones that sense light are the bottom layer of the retina, and light has to pass through the nerves and blood vessels to reach them. Similar imperfections of the human body defy the existence of truly intelligent planning of the human form. As Collins makes clear here and elsewhere in his book, imperfections are expected given evolution but unexpected given intelligent design. Whereas evolution is a tinkering process that often produces suboptimal organisms, matters are different for an intelligent designer. Collins believes ID advocates have in mind a benevolent God who creates by direct supernatural fiat. Such a being would create a perfect eye, Collins thinks. In fact, Collins's line of reasoning implies that, if scientists discover that the eye is suboptimal for vision in the present, then they can rightly conclude that God did not miraculously create the eye in the past. That is, God would ensure the optimality of the eye in, or to, the present day. So, if we discover a suboptimal eye, this fact favors evolution over direct divine design. More precisely, if evolution had produced the eye in the past, it would not necessarily be completely ideal for vision in the present. If God had created the eye by direct miracle in the past, he would have ensured that it is completely ideal for vision in the present. The vertebrate eye does not appear to be completely ideal for vision in the present. If the evidence is predicted by one hypothesis but contrary to the prediction of another, then the evidence supports the former hypothesis over the latter. Thus, a less than completely ideal vertebrate eye supports the evolutionary hypothesis over the divine miracle hypothesis. A few observations about the argument as a whole are in order. First, it's a scientific argument. Collins includes it under the heading Scientific Objections to ID. More importantly, the evidence cited in the argument arises from a scientific analysis of the structure and function of the rods, cones, and retina of the eye. Second, this polemic is a positive argument for evolution, not just a critique of ID or creationism. Despite Collins's heading, which treats the matter as merely an objection to ID, it's clear from the internal logic of the argument itself that the whole point is to show that the vertebrate eye counts as evidence for evolution over ID. I now shift to a few observations about individual premises of the argument. First, it's worth noting that recent research raises serious questions about premise 3, which claims that the eye is suboptimal. Collins's key empirical claim may be flawed. In any case, the theological claim in premise 2 is of primary interest. In it, Collins says that if God had created the eye by direct miracle in the past, he would have ensured that it is completely ideal for vision in the present. Note that the premise is in the subjunctive mood, it states what God would have done in the present if he had performed a miracle in the past. In addition, the claim is indispensable for Collins's argument. If premise 2 is removed, then the argument is no longer logically valid, and the conclusion literally does not follow from the premises. In fact, like many other theistic evolutionists, Collins strongly emphasizes biological imperfections as important evidence for evolutionary theory over creationism or ID. All such arguments depend on suboptimality theology similar to that of premise 2. Collectively, my observations about premise 2, as well as the argument as a whole, can be summarized thus. Collins's scientific argument for evolution, based on the vertebrate eye, relies on an indispensable subjunctive claim about what God would have done in organic history had it been the case that he miraculously created the eye. A few concerns now surface. Importantly, while I focus on Collins's particular argument, similar observations apply to virtually all other theology-laden arguments given by theistic evolutionists, and others, for evolutionary theory. First, Collins provides no justification for his theological premise. He asserts it without any argument or citation from the Bible, creeds, theological texts, or non-religious sources. This is especially troubling given that, as noted above, premise 2 is a subjunctive claim. It asserts what God would have done in the past, contrary to what he actually did. On what basis does Collins know this bold counterfactual? Second, Collins does not borrow premise 2 from his rivals. Neither ID nor creationism entail, or make probable, this theological claim. Instead, Collins inserts his own sectarian theology into the discussion. Third, Collins's partisan claim ignores relevant biblical doctrines like the fall, in which, according to some scholars, the created order itself experiences decay and disorder. On this interpretation, a degree of suboptimality in creation is actually expected. A wide array of theology-laden arguments for evolutionary theory share similar features. These arguments frequently rely on partisan, subjunctive theological assertions as a crucial part of the scientific justification for evolutionary theory. God talk is indeed alive and well in evolutionary biology. Yet such discourse clearly violates methodological naturalism. Example 2, God and flagella. Theistic evolutionists have more in their arsenal than just arguments that rely on theological claims, of course. Indeed, in light of the last section, some theistic evolutionists might contend that they can set aside theology-laden arguments for evolution and still make a strong empirical case for evolutionary theory over its supernatural rivals. All they need to do is use theology-free statements to attack God hypotheses and to bolster evolutionary theory. But this objection, even if correct, is irrelevant. Methodological naturalism prohibits any assessment of theological theories within science, even when this assessment uses only theology-free statements. Consider, for example, Kenneth Miller's widely praised critique of Michael Behe's irreducible complexity argument. Miller, a theistic evolutionist, uses scientific methods, sources, and data to establish non-theological claims, which he then deploys both to undermine Behe's intelligent design view and to support evolutionary theory. To understand Miller's argument, we ought to recall Behe's position. Using the famed bacterial flagellum as an example, Behe's argument can be represented as follows. Intelligent agency, rather than unguided natural processes, is the best explanation of irreducibly complex biological entities. The bacterial flagellum is an irreducibly complex biological entity. Thus, intelligent agency, rather than unguided natural processes, is the best explanation of the bacterial flagellum. Miller attacks both premises. Consider premise 2 first, which holds that the bacterial flagellum is irreducibly complex. Miller says this claim can be put to the test in a very direct way. If we are able to find contained within the flagellum an example of a machine with fewer protein parts that serves a purpose distinct from motility, the claim of irreducible complexity is refuted. The flagellum does indeed contain such a machine, a protein-secreting apparatus that carries out an important function even in species that lack the flagellum altogether. A scientific idea rises or falls on the weight of the evidence, and the evidence in the case of the bacterial flagellum is abundantly clear. The very existence of the type 3 secretory system shows that the bacterial flagellum is not irreducibly complex. In other words, Miller argues something like this. If the bacterial flagellum is an irreducibly complex biological entity, then we should not find that the bacterial flagellum contains a machine with fewer protein parts than the flagellum, and which serves a purpose distinct from motility. But we do find that the bacterial flagellum contains a machine with fewer protein parts than the flagellum, and which serves a purpose distinct from motility. Thus, the bacterial flagellum is not an irreducibly complex biological entity. Pretty clearly, Miller's argument presupposes the empirical testability of Behe's intelligent design hypothesis. Behe's hypothesis predicts the absence of the type 3 secretory system. But such a system has been discovered. So, the bacterial flagellum is not irreducibly complex. As a result, premise 2 of Behe's ID argument, which claimed otherwise, is false, and thus his ID hypothesis is empirically refuted. Notice that, in attacking premise 2, Miller uses only non-theological statements about protein parts, the type 3 system, etc. But he appropriates these statements to attack Behe's ID perspective. Miller clearly engages ID using scientific data and analysis. Unsurprisingly, Miller characterizes ID as a scientific position. This enables him to coherently conclude that ID views are rejected by science because they do not fit the facts. Of course, whether or not Miller's critique is successful is a matter for another time. For now, the key point is that Miller clearly provides a scientific evaluation of ID, in direct contrast to methodological naturalism, which prohibits the consideration of God hypotheses in scientific contexts. Yet Miller does not simply attack ID, he also makes a comparative argument, which claims that evolution, rather than ID, best explains complex biochemical machines. That is, Miller tries to reverse premise one of Behe's ID argument, which favors intelligent agency over unguided natural processes as the best explanation of irreducibly complex biological entities. Miller writes, Michael Behe's purported biochemical challenge to evolution rests on the assertion that Darwinian mechanisms are simply not adequate to explain the existence of complex biochemical machines. Not only is he wrong, he's wrong in a most spectacular way. The biochemical machines actually provide us with powerful and compelling examples of evolution in action. When we go to the trouble to open that black box, we find out once again that Darwin got it right. Miller plainly believes that empirical data about biochemical machines support evolutionary theory over intelligent design theory. Indeed, he thinks the data provide us with powerful and compelling examples of evolution in action. Rather than claiming the supernatural hypotheses cannot be considered within science, Miller provides a careful scientific analysis of ID and evolution, and concludes that the latter prevails. So, in contrast to methodological naturalism, Miller engages a supernatural hypothesis within a scientific context as part of his positive case for evolutionary theory. Miller's approach is hardly novel among theistic evolutionists. One does not have to look far to see that they engage various God hypotheses using scientific evidence and methods, often as part of their positive case for evolution. Doing so is, of course, plainly contrary to methodological naturalism. Part 4: Methodological Naturalism Only Strategy. Recall that theistic evolutionists can choose one of two mutually exclusive strategies to bolster evolution and counter supernatural rivals: 1. Adopt methodological naturalism, or 2. Establish evolutionary theory as scientifically superior to God hypotheses. I have explored the latter strategy above, I now turn to the former. In what follows, I raise two arguments against the methodological naturalism only approach. Argument 1: The irrelevance of scientific evidence. Liabilities abound with a methodological naturalism only tactic. First, by exclusively adopting methodological naturalism, theistic evolutionists are left with arguments that attempt to cast God hypotheses as unscientific or as otherwise unacceptable. Such arguments are familiar: creationism and ID are God-of-the-gaps explanations. They also demean God's ontological preeminence, lessen his explanatory uniqueness, misconstrue the doctrine of creation, fail to be empirically testable, and so on. While I will address some of these arguments shortly, it is important to note that they have already been under intense fire for quite some time. Second, adhering to methodological naturalism yields no epistemic gains for theistic evolution. That is, barring creationism and ID from science does nothing in itself to make theistic evolution more plausible. Theistic evolution simply accepts a biological theory that bears the title scientific, whereas its supernatural rivals are non-scientific. But a scientific designation does not itself make a claim, or set of claims, more likely to be true, or justified, than non-scientific claims. For example, some moral claims, such as the Golden Rule, are not scientific, and yet their designation as outside of science does not mean they are any less likely to be true or justified. Likewise, some other views, such as the caloric theory of heat, are rightly regarded as scientific yet are also clearly false. In fact, history is littered with thousands of false scientific claims. The mere label scientific does not itself make a claim true or false, well justified or poorly justified. Of course, designating a claim scientific can be rhetorically powerful. But the key point is that such a designation does nothing to affect the claim's epistemic features, which are the crucial attributes relevant to its truth and justification. So, while methodological naturalism may lend the patina of plausibility to evolutionary theory, it actually grants no more intellectual credibility to that theory than to supernatural rivals. Methodological naturalism yields no epistemic advantage. Third, and more important, with methodological naturalism in play, theistic. Evolutionists cannot draw upon scientific evidence to critique any God hypothesis. Evidence is off limits from paleontology, molecular homology, comparative anatomy, embryology, genomics, biogeography, and all the rest. For example, empirical data about radiometric dating, which ostensibly suggest an ancient Earth, cannot be utilized at all to offer a scientific critique of the claim that God created the universe about 10,000 years ago. It is difficult to imagine theistic evolutionists giving up such evidence. Yet under methodological naturalism, all scientific evidence is irrelevant to evaluation of God hypotheses. Fourth, with methodological naturalism in play, scientific evidence is impotent to support evolutionary theory over its supernatural rivals. No quantity or quality of scientific data has any bearing whatsoever on the superiority of evolution over creationism or ID. At best, theistic evolutionists can argue that scientific data favor evolutionary theory over other naturalistic, or secondary, theories. But evolution enjoys no such superiority over supernatural theories. Not only are theology-laden arguments for evolution flatly prohibited, but so are theology-free arguments that support evolution over any God hypothesis, as with Miller's critique of Behe. Theistic evolutionists who take methodological naturalism seriously ought to march through every subdiscipline of biology, from biochemistry to paleobiology to genomics, and systematically reject all scientific arguments that purportedly favor evolution over creationism or ID. Surely, this is an exacting price to pay. Finally, by adhering to methodological naturalism, theistic evolutionists arguably have to surrender their most important grounds for evolutionary theory itself. As I have noted, the history of evolutionary theory, past and present, is rife with contrastive arguments against ID or creationism, in one form or another. As mentioned, some of the self-reported best arguments for evolutionary theory by leading biologists entail a comparison to creationism or ID. Arguably, these are the best grounds for belief in evolution. Yet under methodological naturalism, all such arguments are prohibited within science. If some of the top biologists' arguments are verboten, then what befalls the case for evolutionary theory? Of course, the temptation still exists for theistic evolutionists to retain these arguments but file them under a different rubric, for example, by calling them natural theology rather than science. But as I have already pointed out, this is merely superficial relabeling of arguments that draw on scientific data, methods, inferences, articles, and patterns of thinking. If something looks like a duck, quacks like a duck, and walks like a duck, then it's best to call it a duck. Put simply, theistic evolutionists who adhere to methodological naturalism do so at great empirical cost to the justification of their own theory. Surely this ought to give them pause. A navy that has lost its mightiest battleship cannot easily declare victory. Argument 2, Critique of reasons for methodological naturalism. Despite strong reasons against a methodological naturalism-only approach, it is possible that justifications for methodological naturalism are so powerful that theistic evolutionists ought to retain the convention. To assess this possibility, I now turn to these justifications. Broadly speaking, they fall into 5 categories: conceptual, theological, pragmatic, historical, and empirical. The final 2 typically dovetail together, so I will refer to both under the empirical rubric. In what follows, I critique what I take to be the best representative of each category. A preliminary. An initial comment will help prepare the ground. Earlier in the chapter, I mentioned 2 versions of methodological naturalism, intrinsic and pragmatic. To this point, this chapter has focused on intrinsic methodological naturalism, which holds that methodological naturalism is a necessary condition of science. By contrast, pragmatic methodological naturalism is a working version in which methodological naturalism is not a necessary condition of science but rather a general default. On this view, biologists should try to explain natural phenomena by reference only to natural, or secondary, causes, laws, and the like, but they can be open to God hypotheses in principle should empirical evidence or other considerations warrant doing so. By way of brief assessment, this version is not a meaningful type of methodological naturalism. If biologists are open to God hypotheses in principle, then the only way they can know whether, say, a new God hypothesis has scientific merit is to analyze it. Of course, many biologists may be justifiably suspicious about a new supernatural theory, and all biologists are certainly justified in dismissing claims about the divine that are not empirically testable. But God hypotheses, as I've defined them, hold that there is detectable empirical evidence of a divine being. If biologists are to be open to God hypotheses in principle, as pragmatic methodological naturalism allows, then they cannot make a judgment about a new God hypothesis until they examine its conceptual and empirical credentials. But careful empirical scrutiny, in particular, just is a de facto scientific analysis, all things being equal. In these cases, the God hypothesis has been treated as amenable to scientific testing. So, the working version of methodological naturalism really isn't methodological naturalism at all. While it recommends sticking to purely natural factors as a matter of general routine, it also permits a given biologist to consider any supernatural theory he deems worthy of scientific analysis, refutation, or possible confirmation. This opens the door for scientists who accept supernatural theories, or who are against them, to examine, develop, apply, test, vindicate, or falsify these theories. Critics of methodological naturalism will hardly protest. Conceptual justifications of methodological naturalism. Having cleared the ground, I now turn to conceptual justifications for intrinsic methodological naturalism. This justification typically secures methodological naturalism by analyzing the conceptual properties of supernatural hypotheses and contending that such hypotheses lack at least one necessary feature of scientific hypotheses. Elliot Sober, perhaps the top philosopher of biology in North America, has articulated a nuanced objection to creationism, an idea that can be parlayed into a conceptual justification of methodological naturalism. Sober himself actually defends methodological naturalism based on the widespread success of naturalistic theories, an approach I address below. Even so, his critique of the design argument provides a basis for a top-flight conceptual defense of methodological naturalism. Sober's view is quite sophisticated, yet the basic idea is that the most promising way to formulate the design argument is as a likelihood argument, according to which, in this case, the empirical data are said to favor the design hypothesis over the evolutionary hypothesis. But to make this argument, Sober points out that one must know how likely it is that an intelligent designer would create the phenomena in question. This requires knowing the designer's powers and plans. For example, in order to say that it is more likely that a designer would create, say, the vertebrate eye than would evolutionary processes, we must have some grounds for saying that a designer can make the eye and wants to do so. In particular, we must be able to say that it's more likely a designer would make the eye than it is that evolutionary processes would do so. But aside from self-serving prior beliefs about a designer, Sober thinks we don't have any independent basis for the required claims about a designer's plans or powers. Put bluntly, we have no idea what a designer would do. This lack of knowledge means that we cannot predict a designer's actions. Without the ability to generate a prediction, we cannot evaluate a design hypothesis against an evolutionary hypothesis. This means we cannot say that the empirical data favor design over evolution. In effect, we cannot empirically test the design hypothesis when formulated as a likelihood argument. An advocate of methodological naturalism can appropriate this line of reasoning. He can claim that the best formulation of the design argument is a likelihood version, but that this version posits God hypotheses that cannot be empirically tested in the proper way. Unfortunately, God hypotheses, as I use the term, do purport to be scientifically testable. Given that they are intended to be testable yet cannot actually be tested, they arguably fail to qualify as scientific. Thus, the best type of design argument falls outside the pale. There is a lot to be said for this justification for methodological naturalism. It ranks as perhaps the best conceptual apologetic for the convention. Yet it falls prey to a fatal counterexample. Consider the logical, although outlandish, possibility that biologists discover an ancient line of cells with an inscribed message. Elliot Sober's view of the design argument is suspect. Moreover, the Los Angeles Rams will win the 2030 Super Bowl. And, yes, John 3 verse 16 is true. Suppose it comes to pass that, against all odds, the Rams not only win a regular season game but actually make the playoffs and triumph in the 2030 Super Bowl. Wouldn't biologists be scientifically justified to at least consider divine design as a possible explanation? This counterexample holds even if we accept the likelihood framework of the design argument. On this view, we need independent information about a designer's plans and powers. Fair enough. Yet even if it is difficult to articulate what these plans and powers are, or how we know them, in this case surely we do know them. After all, it is patently obvious that the message about sober, the rams, and John 3 verse 16 is the product of design rather than evolutionary processes. A critic might protest that biologists need not concern themselves with unlikely possibilities, including mere logical possibilities like the whimsical message about sober, the rams, and John 3 verse 16. Instead, biologists need only focus on pragmatic and empirical realities. Yet this criticism misses the point. The conceptual justification for methodological naturalism is the matter before us, and this justification holds that the best design arguments, rendered in a likelihood formulation, articulate design hypotheses that rely on concepts or information that are unattainable. In this case, design hypotheses require independent information about a divine agent's plans and powers, yet we have no such information. This justification is neither empirical nor pragmatic. It does not claim that empirical data fail to confirm design hypotheses, nor does it claim that, as a practical matter, design hypotheses hamper fruitful research. Instead, it claims that likelihood arguments are the most promising way to argue for design, yet such arguments posit design hypotheses that are untestable. Pragmatic or empirical factors of the type in question do not alter this deep flaw. Accordingly, this conceptual justification for methodological naturalism ought to hold even in cases as pragmatically and empirically outlandish as the sober, rams, and John 3 verse 16 message. Yet it would be absurd to retain methodological naturalism in the face of this message. Surely the message should compel us, at the least, to put design on the table as a scientific possibility. But methodological naturalism excludes even this modest consideration. The convention implies that no possible empirical data can ever provide good grounds to consider a design hypothesis within science. Such a view is a tad extreme. Theological justifications of methodological naturalism. I now turn to theological justifications for methodological naturalism. These justifications typically contend that the scriptures support methodological naturalism, or that methodological naturalism preserves important doctrines of the faith. For example, Dennis Alexander argues that methodological naturalism protects God's ontological preeminence and explanatory uniqueness, ensuring that he is not treated simply as another explanatory element within creation or as less involved in certain aspects of the natural world than in others. Other theistic evolutionists, like Robert Bishop, believe that the Christian doctrine of creation, when applied to scientific inquiry, naturally favors methodological naturalism. These and other thinkers hold that methodological naturalism suitably maintains the creator-creature distinction, affirms God's gift of creational freedom, preserves Scripture's emphasis on God's normal, mediated way of relating to creation, and the like. By way of reply, it would be quite a task to address all of these justifications in detail. Fortunately, much of the relevant exegetical and theological work has already been done. In particular, c. John Collins has convincingly argued that the scriptures affirm, 1. God's ordinary providence of ontologically sustaining created things and of concurring in their effects, and also, 2. God's extraordinary providence in which he acts in, or on, creation in ways that go beyond the natural powers of creation, which are themselves gifted and sustained by his ordinary providence. In short, God sometimes treats domains of creation differently than he normally does. Moreover, Collins contends that the Bible regards God's extraordinary actions as sometimes resulting in empirically detectable states of affairs. God's special actions can leave traces. Examples include creation ex nihilo, the virgin conception of Jesus, transformation of water into wine, raising of Lazarus and others, the resurrection of Jesus, conversion of sinners, and so on. These considerations hobble many of the theological justifications for methodological naturalism noted above. To illustrate, suppose God acted in an extraordinary way to raise Jesus from the dead. This event reportedly resulted in states of affairs, an empty tomb and resurrection appearances, for example, which were said to be empirically detected by multiple people, John 20-21, Luke 24, Matthew 28, 1 Corinthians 15 verses 1-8. If this occurred as reported in the New Testament, should Christian theistic evolutionists worry about the theological problems raised above? For example, was God somehow less involved in the rest of creation when he was busy raising Jesus from the dead? Or, by raising Jesus, is God's explanatory status reduced to that of a creature? Has God violated creation's alleged freedom, say, to keep dead people as they are? Has God violated his own alleged commitment to mediated actions? Clearly, the answer to these questions is no. An extraordinary act of God that leaves empirically detectable effects can avoid all such quandaries. Likewise, suppose God acted in an extraordinary way prior to the advent of humans, say, by creating the first life on earth. In this case, do the theological problems noted above suddenly arise? It is exceedingly hard to see how. Moreover, suppose this extraordinary divine action was such that humans could eventually detect it using careful observation, orderly analysis, established patterns of reasoning, and other tools of science. Do untoward theological problems now rear their heads? Again, it's hard to see how. All that's happened is that God has treated one part of creation differently than he ordinarily does, and has done so in a way amenable to systematic human investigation. If the good Lord chose to sign his handiwork, Christians need not demur. As far as I can tell, the biblical data do not favor the adoption of methodological naturalism in biology. Yet suppose it turns out that exegetical and theological evidence are underdeterminative with respect to the question of methodological naturalism in biology. In this case, why not simply go to creation to decide the matter? Given that Christians have long regarded creation as radically contingent, God could have made it any way he chose. Perhaps it's best simply to investigate as carefully as we can. If the glory of God is to conceal a matter, as a proverb intimates, Proverbs 25 verse 2, then perhaps the glory of scientists is to investigate. Of course, to scientifically examine whether biological phenomena, or history, manifest God's extraordinary action just is to set methodological naturalism aside. If one is genuinely open to both possibilities, either God acted in a scientifically detectable way or he did not, then methodological naturalism has already been discarded. If the book of Scripture turns out to be unclear on the matter, why not simply try to read the book of nature? Pragmatic justification of methodological naturalism. Perhaps more promise lies with a pragmatic justification for methodological naturalism. At a practical level, God hypotheses are said to inhibit scientific progress, whereas naturalistic hypotheses enable the progress of science, in both the past and the present. A response to this objection hinges upon what constitutes the progress of science. If progress is understood in non-realist terms, then methodological naturalism is allegedly justified because, whether naturalistic hypotheses are true or false, they uniquely generate fruitful lines of investigation. In my view, Del Ratch has already successfully critiqued this view. In particular, a reasonable argument can be made that, at times, naturalistic approaches have inhibited research whereas some theological approaches have been quite fruitful. On the other hand, if progress is construed in a realist fashion, so that progress is measured in terms of the qualitative and/or quantitative increase in naturalistic hypotheses that are true, then the objection is a version of the empirical and historical justification for methodological naturalism, which I address next. Empirical and historical justification for methodological naturalism. We are led, then, to the empirical and historical justification for methodological naturalism. On this view, the pattern of scientific discovery over hundreds of years is marked by the growing explanatory power of naturalistic, or secondary, theories and also the diminished explanatory power of their testable, theistic rivals. On realist grounds, this pattern suggests that, as a category, naturalistic hypotheses are true, approximately true, or at least significantly more likely to be true than their supernatural counterparts. Accordingly, there is epistemic reason to block the incursion of hypotheses into science that have a track record of being empirically substandard. I have addressed this view in detail elsewhere. Here, I'll mention just a few points. First, this justification for methodological naturalism implies that what separates science from non-science is truth, approximate truth, or the property of being more likely to be true than a rival. But demarcation along these lines is tenuous. Surely truth, or its cousins, is not a necessary condition of science. Such a demarcation plainly leads to absurdities. Any past or present hypothesis, no matter how fruitful or significant, can no longer be deemed scientific if it is no longer considered true, approximately true, or much more likely true than its rivals. Thus false hypotheses like Darwin's pangenesis view of heredity and Copernicus's model of the solar system, with its perfectly circular orbits, are decidedly non-scientific. On this view, naturalistic origin of life research has fallen on hard times. At present there is no consensus in the field, but only a number of hypotheses on offer. Insofar as these hypotheses are mutually exclusive, at most only one of them can be true. Does that mean the rest are literally non-scientific? The empirical justification for methodological naturalism fails for two additional, related reasons. First, recall that it draws on a historical pattern of naturalistic theory success. Yet even if, for the sake of argument, past supernatural theories have a poor track record whereas naturalistic theories have a strong one, it hardly follows that a forthcoming new supernatural theory, based on updated evidence and methods, ought to be excluded from science automatically. A basketball program with a weak legacy can still field a good team now and again. Second, it remains unclear whether naturalistic, or secondary, theories actually do enjoy a relevant pattern of explanatory success in the history of science. It is true that naturalistic theories have increased in number and explanatory power since the scientific revolution. But the relevant question is whether this increase manifests a historical pattern sufficient to warrant barring God hypotheses altogether from biology. Much of the success of naturalistic explanations have occurred in bench sciences, like physics and chemistry, which focus on the day-to-day workings of natural objects, events, and properties. Yet in the Judeo-Christian tradition, God hypotheses typically have not been invoked in these areas. Instead, these hypotheses have been, and are, generally posited to explain the origin of novelty in the history of the cosmos, such as the origin of the universe, planetary systems, geological features, life, biological complexity, consciousness, and the human mind. Strikingly, in these areas naturalistic theories have had mixed success. There have been some successes to be sure. Theistic evolutionists would point to Darwinian evolution as the best explanation of biological complexity, for example. Yet even granting this, and other, alleged successes, naturalistic approaches have arguably failed to explain the origin of the universe, life, consciousness, and the human mind. And these failures have persisted from the ancient Milesians to the present day, over 2,000 years of intellectual miscarriage. The upshot is that reconstructing the historical pattern of naturalistic, or secondary, success is not so simple. Many complexities are close at hand, and these complexities are part of the point. The alleged historical pattern may not be as clear as one might think. Of course, a critic might counter that the pattern in question is not just about past naturalistic and supernatural theories but also about present ones. In this case, the empirical justification for methodological naturalism also draws upon contemporary scientific data, methods, and inferences to argue that naturalistic theories enjoy explanatory success whereas supernatural theories flounder in explanatory failure. In the context of biology, this means that the scientific success of current evolutionary theory, juxtaposed to the failure of contemporary creationism and ID, justifies barring the latter duo from biology. But wait. Methodological naturalism holds that supernatural theories cannot be considered within biology. Science is silent about them. Yet, this justification of methodological naturalism depends upon the scientific superiority of evolutionary theory over its theology-laden opponents. It uses the very grounds it excludes. The empirical justification for methodological naturalism quietly draws upon the alleged scientific superiority of evolutionary theory over its supernatural rivals as the basis for declaring that these very rivals are not worthy of scientific scrutiny. Rivals cannot be tested and yet have failed all tests. This is incoherent, like saying that the Duke basketball team failed to make the NCAA tournament because they lost in the first round. The empirical justification for methodological naturalism undermines itself. Moreover, this justification begs the question. Arguably, the fundamental contest between evolution and its theological rival centers on which approach best explains biological complexity. Yet the empirical justification of methodological naturalism assumes the explanatory superiority of evolutionary theory over its supernatural counterparts. That is, this justification grounds the credibility of methodological naturalism on the assumption that evolution successfully explains biological complexity whereas creationism and ID do not. Yet this is the very point at issue. Is evolutionary theory explanatorily superior? Or is a given supernatural theory superior? These are precisely the questions that creationists and intelligent design theorists try to answer. The empirical justification of methodological naturalism bars their answers from science because it has already decided that evolutionary theory is superior. It presupposes a self-serving point of view, and so begs the question at hand. Stepping back for a moment, there is much more to be said about methodological naturalism, both for and against. For now, in light of the apparent weaknesses of some of the best justifications for methodological naturalism, coupled with the liabilities of methodological naturalism noted above, theistic evolutionists may wish to consider a more open approach to science. No doubt some theistic evolutionists will demur, however. They will choose to retain methodological naturalism. In one sense, I welcome their persistence. If they preserve the convention, then they ought to systematically repudiate all theology-laden arguments for evolutionary theory and also abandon all scientific engagement with creationism and ID. Once they have done so, they should articulate whatever grounds remain for evolutionary theory. My suspicion is that their case will be thin indeed. Part 5, Final Thoughts. Regardless of whether methodological naturalism is intellectually justifiable, the convention itself retains enormous rhetorical power. It allows theistic evolutionists to designate their favored theory as scientific, while deeming theological rivals as non-scientific. Doing so boosts the perceived intellectual credibility of evolutionary theory. This dynamic is nothing new. Similar maneuvers that purport to distinguish science from non-science have been part of the Western tradition for a long time. In ancient times, Aristotle distinguished between scientific and technical knowledge as a way to embarrass rival Hippocratic physicians. In the early 17th century, Galileo lobbied for the title natural philosopher rather than mere mathematician in order to increase the credibility of his views. In the late 17th and early 18th centuries, Cartesian natural philosophers attacked Newton's account of universal gravitation as unscientific because it lacked a proper mechanism. In the 19th century, Darwin claimed special creation was not a scientific explanation just when the tide turned in favor of common ancestry. And in the 20th century, German scientist Walther Nernst shunned the Big Bang theory on the grounds that science, by definition, requires an infinite cosmos. The melee continues. Philosopher Larry Laudan aptly characterizes this pattern. No one can look at the history of debates between scientists and pseudoscientists without realizing that demarcation criteria are typically used as machines to go in a polemical battle between rival camps. Methodological naturalism, like all such maneuvers, often relies on the prestige of science as a substitute for careful analysis of competing theories. It exchanges real engagement for the veneer of respectability. In the end, theistic evolutionists must make their choice. The case for evolutionary theory time and again involves theological claims or comparisons with theology-laden rivals, in direct violation of methodological naturalism. If theistic evolutionists wish to retain a maximally strong case for evolution, if they wish to keep their battleship, they should reject methodological naturalism. It matters little whether natural or supernatural theories have titles like scientific or non-scientific. What matters is the empirical and conceptual credentials of each theory. What matters is which one best explains biological complexity. What matters, in short, is which one is true.